예, 반갑습니다. 한미에너지협회 조세킴 회장입니다. 올해 코비드-19으로 인해서 저희가 버추얼 심포지엄을 이렇게 처음으로 갖게 되었습니다. 무엇보다도 모든 분들 건강에 조심하시고 항상 백내에도 편하시길 바랍니다. 올해 당협회 심포지엄은 수소 에너지를 활용해서 친환경 비행기 시대를 여는 기술 및 기업들의 진행 현황을 이해할 수 있는 귀한 시간이 되도록 관련 분야 최고의 기업들을 모셨습니다. 이 심포지엄에서 최신 기술 내용을 알려달라는 요청에 흔쾌히 수락해 주신 강사분들께 깊이 감사드립니다. 그리고 오늘의 행사를 위하여 후원해 주신 외무부와 박경재 LA 총영사님께 또한 감사드립니다. 마지막으로 오늘 이 행사를 위해서 뒤에서 묵묵히 수고해 주시는 분들, 특별히 사회를 맡아주신 샘민 교수에게도 깊은 감사를 드립니다. 저희가 이제 처음으로 이거 버추얼 심포지엄을 하다 보니까요. 진행상 매끄럽지 못한 부분도 있을 수 있음을 미리 양해를 구합니다. 감사합니다. Hello everyone, good morning and good afternoon. I am Jose Kim, Chairman of Korean American Energy Association. This year we have a virtual symposium due to COVID-19. I hope everyone is healthy more than anything. This year's symposium invited the best companies in the relevant field to help them understand the technology and the progress of companies in the era of eco-friendly airplanes using hydrogen energy. Thank you very much to all speakers who readily accepted the request to inform us of the latest technology at this symposium. And thank you to the Ministry of Foreign Affairs and Gyeongjae Park, the Consul General in Los Angeles, for supporting today's event. Lastly, I would like to thank you all of you for your hard work behind this event, especially to moderator Professor Semin. Since this is our first virtual symposium event, we ask for your understanding in advance that there may be some areas that are not smooth in progress. Thank you so much. 제가 이제 환영사를 했습니다. 뒤이어서 오늘 그 축사를 우리 박경재 LA 총영사님께서 해주시겠습니다.
예, 안녕하십니까. 저 박경재입니다. 오늘 많이 바쁘실 텐데 그 수소에너지와 도심 항공 산업에 대한 관한 주제로 2020년 에너지 심포지엄에 이렇게 많이 참석을 해주셔서 감사를 드립니다. 무려 100명 이상이 되는 분들이 참석을 하신 것 같은데 감사를 드립니다. 특히 오늘 행사를 준비해 주신 한미에너지협회 조셉 김 회장님과 오시상공회의소 고려한 정 회장님, 그리고 한국에서 아주 이른 시간에 발표를 해주실 국토교통부 2당 미래 드론 교통과장님, 제주도 디지털융합과 박찬혁 팀장님, 그리고 이제 미국에서 제로에비아 발 미프타코프 CEO님, HS 솔루션의 스티브 햄비 대표, 해피테이크업의 다니엘 맥닌 CEO, 바르티니 에어로의 일리아 카니코프 CTO에게도 깊은 감사를 드리며 좋은 발표를 기대하겠습니다. 오늘 심포지엄의 주제는 수소에너지와 수소항공체 기술은 지금 한창 코로나19 때문에 많은 논란이 되고 있는 세계 환경보호에 큰 도움이 될 뿐만 아니라 참여하는 모든 나라가 새로운 경제 성장의 동력을 확보할 수 있을 것으로 생각을 합니다. 예, 우리나라 정부에서도 지난 7일 날 국제에너지기구 IEA와 함께 2020년 국제수소에너지 컨퍼런스를 개최하는 등 미래 에너지 및 항공산업의 핵심이 될 수소에너지와 첨단 드론 기술 개발을 적극 지원하고 있습니다. 캘리포니아주에서도 수소에너지 산업을 미국에 내에서 가장 적극적으로 지원을 하고 있으며 지난 9월 23일에는 2035년까지 가솔린 엔진을 모체로 하는 새로운 차를 금지하는 법령을 제정한 바 있습니다. 또한 캘리포니아 내에서는 2000년 9월 현재 45개 정도밖에 안 되는 수소 충전소를 2030년에는 1000개 가까이로 대폭 확대할 계획으로 있는 걸로 알고 있습니다. 이러한 측면에서 우리 이번 심포지엄은 한미 양국의 첨단 기업 및 한국 정부기관이 발표에 다수 참여해서 개발 현황과 미래 전략을 공유하는 자리로 매우 뜻깊은 자리라 할 수 있겠습니다. 오늘 깊이 있는 토론과 참여를 통해서 미래의 기술 발전상과 새로운 비즈니스 개척의 아이디어가 활발하게 공유되기를 기대합니다. 감사합니다.
예, 다음 이어서 오렌지 카운티 한인 상공회의소의 브라이언 정 회장님의 축사가 있겠습니다.
안녕하십니까? Hello, I am Brian Chung, president of the Korean American Chamber of Commerce here in Orange County. I would like to commend the Korean American Energy Association for hosting the 2020 Hydrogen Energy and Urban Air Mobility Symposium. I also would like to express gratitude to the chairman, Jose Kim, and the Consulate General of Korea in Los Angeles for your support in the event. Hydrogen will become a clean energy source for the next generation in not only serving the automotive and rail industries, but also in the near future, the aviation industry as well. Hydrogen is also known to be more efficient than carbon-based fuels. Yes, there are many issues to overcome, such as cost, delivery, and safety. But in terms of efficiency, hydrogen is an important element that business people cannot miss on. Many governments, including the United States and Korea, and companies have already set hydrogen goals to use in commercial aircraft. They are actively working on various projects to achieve the goals. At this time, it is very timely that KAEA hosts this symposium. I hope the 2020 Hydrogen Energy and Urban Air Mobility Symposium provides all of you learning opportunities in the development status of various hydrogen aircraft around the world and understand the prospects for future aviation services. In consideration to everyone's health and safety during our COVID-19 pandemic situation, I especially want to thank the KAEA for providing such a great symposium in the form of a virtual platform. Once again, congratulations and thank you.
네, 감사합니다. Now it is the time to hear the speakers. From now on, Sam Min, the professor of Cal State Long Beach, he will guide us. Let me introduce Sam Min, professor.
Thank you. Thanks for your introduction, Joseph. I'm Sam Min. I'm the chair of marketing department at Castle Long Beach, but I'm visiting now Korea University now. So let me check first. The local time in Korea now is 6:10 a.m. I know that it is now about 2 p.m. In US. And I also know that some of them are participating from England. I think their local time must be 10 p.m. So anyway, some of you still waking up, but anyway, I like to make this panel exciting and to try to make everyone participate in this discussion. First, I'd like to let you know that everyone who are listening to this symposium, you can participate in you could ask questions. We open the chat box. You can check the chat box, and while the panelists present their materials, you may type in your questions. My role in this symposium is moderator. I like to try to do my best to summarize all your questions and ask questions on behalf of you. Now, let's get it started. First, the speaker of the symposium. This is a keynote speaker. I'd like to introduce Mr. Yi Rang, the Director of Ministry of Land, Infrastructure, and Transport. He will be presenting about Korean UAM roadmap. Mr. Lee, would you start your talk?
Yeah, thank you for great introduction, Mr. Sam Min. And then it's very honorable for me to have a presentation on the KUM roadmap and Team Korea. And before I get started, I would like to say congratulations to this great symposium. And then Actually, as Mr. Sammin said, that it is very early in Korea, so please understand that I'm making up. But anyway, I'm doing my best, and yeah, let me start. So, as mentioned in the opening remarks and greetings, these days Korean government is putting a lot of stresses on hydrogen and economy and UAM business. So we have to figure it out how we can mix it uh, in a harmonized way. So I think this symposium can be a good chance to discuss on this issue. And then I hope that you, all the participants, can have a good sense of about what's going on in Korea. So let me begin my slides. Okay, everybody can see my slides?
Looks good.
Yeah, okay, thank you. So, first I would like to go explain about the KUM roadmap, which you released last June. So, it is meaningful that this roadmap was decided jointly by related ministries, such as Molit, Songhai Ministry, and Ministry of Commercial and Industry, and Ministry of Treasury, and so on. And at the Innovation and Growth Strategy meeting, presided over by Deputy Prime Minister for Economic Affairs. As you all know, UAM industry is a rising industry, which with a estimated market size of around 730 trillion won by 2040. Based on this expectation, a lot of companies like Uber Elevate, Hyundai Motors, and Hanwha Systems are taking part in developing concept of operation and eVTOL and other new vehicles, such as hydrogen UAM vehicles. Initial commercial service is expected to 2023 to 2025, and market expansion is expected after 2030. The reason why we made this roadmap is that UAM is only possible with the support of proper regulation from government side. So you can see the vision and purpose of the roadmap. Through UAM, people can have new transport means over traffic congestion of the city. Korea has the same situation of heavy traffic too. Especially Seoul metropolitan area as one of the most populated area in the world has good potential for UAM operations. In addition, we can facilitate new industry and create quality jobs. As Korea is good at manufacturing and adopting new technologies, once the UAM market is open smoothly, Korean economy can enjoy the fruits of new industry for sure. In addition, I think that we have great ICT infrastructure too. In the roadmap, we suggested 4 stages based on UAM technology and market maturity. It is preparation, initial, growth, mature stage. The critical timing is second phase. By 2025, we are aiming to have the first commercial passenger service in Korea is our goal. We will design routes and build initial multiport connecting inner and outer parts of the city. Most likely airport shuttle. After 2030, we expect UAM market expanding and could see many flights in the center of the city. From this point, operators are likely to generate profits. From 2035, UAM will become public transport means. There will also be routes from cities to cities, and autonomous flights are possible that will lower the fare significantly. To prepare for the first commercial service in 2025, we have to prepare a lot of things, especially revision of related laws and regulations from this year to 2024, which is preparation stage. Tests and demonstrations should be conducted in the same time to check safety and feasibility. It's an aggressive goal and very busy schedule, but I think it's doable. To make it happen, we suggested 6 strategies. First is setting up regulations for securing safety. The most important project is Korean UAM Grand Challenge. It is for collecting data to develop regulation and checking safety, as well as promoting public acceptance. This program is similar to NASA's Advanced Air Mobility National Campaign. We are going to test and evaluate eVTOL and new vehicles that would like to operate in Korea. From 2022, the first flight can be seen in the remote test site, which is away from the populated urban area, and tests should continue to 2024 for 2 to 3 years. From 2024, I hope tests can be started near airport area as well as in the part of city downtown to prepare for the first service in 2025. Certification standard can be prepared based on active cooperation with FAA and EASA. Even though Korea has good skills in manufacturing cars and ships, we had limited experience to produce airplanes. It is mainly due to lack of certificate experience in civil aviation area, I think. To catch up this gap early, we are going to learn hard from FAA and EASA and cooperate with private companies like Hyundai Motors and Hana Systems very close. Furthermore, since Korean companies are lack of certificate experience, we are going to establish certificate support center funded by government and help private companies learn process and key factors of acquiring certificate. Developing infrastructure and operational standard will be available from the data of KUAM Grand Challenge and cooperation with private sector and international civil aviation authorities too. Second strategy is building UAM ecosystem to strengthen private sector. As a second mover, Korean vehicle companies need a lot of flight experience. MOLIT, so my ministry, will support that by free special zones and demonstration routes. In the free special zones, temporary flight permit and special airworthiness certificate can be exempt. So this can help the vehicle companies developing their vehicles in the early stage. In addition, many research and development projects funded by government are going on, like developing UTM and prototype body, upgrading battery capacities, and so on. As you all know, it took almost 100 years for the air transport system to be completed. The key is to minimize burden of existing aircraft transport system and develop new way of traffic management for UAS and UAM. In this sense, I agree with FAA's UAM concept of operation, volume number 1, that traffic management is conducted by similar structure of UTM, community-based cooperative traffic management system. And we are going to develop related systems in a timely manner. Essential data such as weather, noise, communication, 3D maps, and disasters can be collected by the government and spread to private players in need. It does not mean that government is providing services directly, but help UAM ecosystem established and mature. So we are gonna do just collector of the data and provide it to private companies. Third is to gain public acceptance. Still, many Koreans think that UAS and UAM is dangerous and nuisance. Especially in Seoul metropolitan area, there are a lot of high rises and apartment complex. So the use of UAS and UAM can be very limited, and people can think that it is not that safe to have it. So we have to take a step-by-step approach. Cargo service first, and then tourism and public services like firefighting, law enforcement, and medical ambulance before transportation service in urban area. Education and training human resources is another way to gain public acceptance. Furthermore, we will have the first UAM public demo flight in the middle of Seoul this November. I think this event will help Korean people understand the UAM concept and increase public acceptance for the new vehicles. Fourth strategy is to build infra and connected transport for convenience. To have vertiports at the right place where demands and revenue can be generated is key factor for UAM success. Basically, building vertiport is funded by private sector, but government can help discover sites and link it with multi-transit center plan. For this, we will work closely with the local government. In Seoul, we have commercial water taxi service operating on Han River, but as the location of docks are far from public transport, it is not popular, less than 10 passengers per day. So we have to take lessons from this experience to secure good places with better accessibility. To simplify boarding security check is another important area that government can contribute. We are doing some research and development projects regarding this subject too. Fifth strategy is building fair, sustainable, and healthy ecosystem. We will design UAM business closer to taxi or bus service rather than aviation. Also, developing and distributing UAM insurance standard model is important subject. To acquire abundant data for UAM vehicle is critical, and KUAM Grand Challenge can be a good chance to have it. Flight route allocation will be done based on service and safety assessment result. At first, Mollit is in charge of allocation, but as UAM market mature, we are thinking of devolving authority to local government in the long run. Last strategy is expanding international cooperation to meet the global standards. Everyone agrees that close exchanges with the international community are essential. So we are going to have regular meetings with international civil aviation authorities like FAA and EASA. Actually, I can say that we are working very close with FAA and EASA now. Also, two assistant organizations of Mollit, KIAST, Korean Institute of Aviation Safety Technology, and KARI, Korea Aerospace Research Institute, joined ASTM and EuroCAE this year. In addition, we are open to the cooperation with foreign companies to open the UAM market in Korea too. I think KUAM Grand Challenge can be a good opportunity to develop details of cooperation. From now on, let me introduce UAM Team Korea that established on last June based on the KUAM roadmap. UAM Team Korea is a policy committee led by Vice Minister of Mollit, and 37 organizations have membership now. As UAM market grows, the number of participants is likely to go up. Membership is only open for Korean organizations that has any kind of role or concrete business plan for UAM market. Any area of developing vehicles or infrastructure or operation and so on. The reason why we create this committee is for public-private cooperation, because in the KUM roadmap, there are so many subjects that should be done by various players like central government, local government, private companies, academia, and public agencies. So we thought that we had better gather all related organizations and move forward together. In this way, we can minimize the obstacles or arguing and then move forward together very efficiently. We had a big launching ceremony hosted by the Minister of Mollit. In the center, you can see my minister, Kim Hyun-mi, in the middle. It is uncommon for the minister and the vice minister to attend to a single event together. So from center, my minister is in the middle, and right side of her, my vice minister is saying hello. This shows Mollit's active will to make UAM operation happen. Another photo from the launching ceremony day. You can see the Hyundai Motors SA-1 aircraft mock-up behind. So that day, all the KUAM Team Korea members participated, including Hyundai Motors and Hanwha Systems. UAM Team Korea meets regular base once or twice a year, and the working committee meets at least once a quarter to discuss the progress of the roadmap, including policy and technology. I'm the leader of the working committee, and we are working closely with passion. Main task of Team Korea is to implement KUAM roadmap as planned. Also, discovering new policies and research and development projects is important too. You can see more details of Team Korea text. I would like to stress one thing. Around 2023, UAM Special Act will be prepared based on co-work within the committee to support UAM operation in 2025. I'm sure Team Korea can promote driving force and help open urban sky together. That's all I have today, and thank you for listening.
Thank you. Thanks for your presentation, Mr. E. Everyone who participated in this symposium, the chat box is open for questioning. If you have any question, please type in your question. While we are waiting for your questions, I have a couple of questions. First question I'd like to ask you, Mr. E, is how KUAM team has been organized. I mean, anybody can join the team at this time?
So we decided the initial member companies or organizations based on this criteria that any kind of it should be basically Korean companies or organizations, and then second is that they should have the critical concrete plans for the UAM business or any kind of contribution to everybody who joined in this team. So in this sense, so I can show you the slide. So we have the industry members for like Hyundai Motors and Hanwha Systems, and we thought that these two companies is as the vehicle manufacturers and potentially operators too. And Korean Air is the renowned civil aviation operation company in Korea. And SK Telecom is for the UAM and UTM service too. And Tucson is famous for the hydrogen drone, which is good for cargo drone, long distance. So for like this, these companies has all the concrete business plan for UAM business in the future. And the other academia, so a lot of universities in Korea has very good passion to study in this area hard in the future too. And the important thing for this team is that all the related government ministries are in for like Ministry of Defense and Ministry of Economy and Finance and so on. So we can do all the supports from the other ministries as well as MOLIT. So I think that this business can go smoothly with the help of these ministries. The reason why we have the local governments in this team is that we thought that local government's role is very critical to have UAM service in urban area, especially with the construction of the multiports. So local governments have authority to give them construction permit, and they can secure the site of the multiports and so on. And we need them to secure the public acceptance too, I think. So in the long run, their role is very critical. That's the reason why we have them in our team. And all other related organizations are in the team too. So you may see a lot of name of the organizations, and all are related with the operations or multiports or communication and so on. So we have them all. I can say that we have all the related organizations for now in Korea. We related with this new business. And actually, after we announced this roadmap and Team Korea plan, a lot of new companies called to my division that we are gonna take part in this team too. But I think that we are gonna go this membership. We are gonna well, what I have to say. So we are open to have a new member, but based on the their what can I say business plan. So they should contribute anything to the member to members in Team Korea now. So they should not just learn and listen. They should do something for everyone, So that's our criteria. And actually, we are open to have new members in the future. So we'll see.
Okay, thank you. Since I'm in academia, I have a question. This question is probably more personal question. What is the responsibilities of what is your expectation from academia in this UAM Team Korea?
Yeah, so I can say the most critical stuff is that developing human resources. So as you might know, Korean civil aviation industry is focused on just operation and air traffic management. We don't have enough experience of manufacturing civil aviation aircrafts because of the lack of certificate experience, I think. So that means that we don't have enough people to support the new business of UAM. So lack of very professional experts in this area. So in the long run, we need to acquire or secure a lot of good students and good human resources for the industry. And second is to develop the technology. So lately, government is doing a lot of research and development projects regarding UAM business, and we are gonna expand more and more projects in the future. So in this sense, academia's role is very important. Yeah.
Thank you. Thanks for your answer. Explaining who could participate and how. Another question I have is, it was introduced. This plan, this roadmap was presented this year in June.
Yeah.
My question to you is, this is clarification question. So this is approved by Korean government.
Yeah, I can say that. Yeah,
right?
It's government plan, government roadmap.
Okay, this is a 15-year roadmap. Have you discussed about any budget figures?
Yeah, right. It is important to have the budget plan too. So actually, we didn't suggest the concrete number in the roadmap, but in the roadmap, we suggested that Korean government would like to invest a lot of taxpayers' money into this new business. So just a broad vision and direction, and then we are in favor of invest taxpayers' money to develop new industry, and we are figuring out what kind of projects, a specific project we are gonna do for now, from next year, and a lot of research and development project in the long run. So we didn't suggest. My answer is that we didn't suggest any kind of concrete number yet, but we are gonna do. We are gonna support this business. Yeah. Anyway, and then we are developing the details of the government invest.
I see. I got it. The following question from me is, this is a 15 years of a long-term, very ambitious plan. In order to get a commercial flight by 2025, I think there should be a lot of things you should do. Is there any, earlier you said you're gonna host an event this year, November.
Yeah.
Can you explain more detail about the event?
Yeah, okay. So for now, we don't have any kind of, how can I say, qualified good vehicles from Korean company yet. So they are mostly second mover. So for now, we are gonna trying to have the first public demo flight using falling vehicles, and then we are gonna thinking of the situation about COVID-19, but anyway, we are gonna do it, even though it can be just broadcasted online. So anyway, we are gonna do it. I'm saying, and then the reason why we are doing this project is that I can say there is two reasons, And first is to gain the public acceptance. So after we announced the KUM roadmap in public in June, many Koreans said that, wow, it cannot be done by 2025. It can be done 2200, something like that. So I can totally agree with them because they never saw UAM business plan or UAM vehicles. So in this sense, I thought that we had to better show them the real feature of the UAM vehicles to increase their understanding of new business and gaining more good, better public acceptance. And second reason to have this event is that we can be prepared, the Mollik can be prepared to give them certificate in the future. So to do this kind of event, Mollik should secure the safety for the flight plan and the vehicle. So, but in the future past, we didn't have any kind of standard to what can I say, to evaluate the safety of the new vehicle because it's brand new and there are no publicized, no published standard yet worldwide. So we made a very simple standard inside of ourselves by Mollit, and we are gonna test the foreign vehicles based on this newly developed standard for this event, and then we can give them special airworthiness certificate based on this new standard. So this kind of experience can give our Korean companies to get certificate very smoothly in the future too. So those are two reasons that we are gonna doing this public demo flight.
Do you know the date of the demo flight in November?
Yeah, it will be in 12th of November.
I see.
But it's up to weather. So our main goal is to 12th of November, but we'll see and finger crossed
Yes,
about good weather. Thank you.
I hope so too.
Okay,
look
I have
forward to it.
yeah, I have one question.
Yeah, yes, please, Joseph.
Okay, and on your presentation, you mentioned Korean government will welcome foreign companies to join in KUAM Grand Challenge from 2022.
Yeah.
So can you explain more how to participate
Yeah.
for the foreign companies?
Yeah, that's very good question, I think. So basically, the most important project that we suggested is KUN Grand Challenge, and it is very similar to NASA's national campaign, as you all know. And I don't think that with only Korean companies we can achieve the goal. We can prepare all the needed aspects of the program. So we need the help from the foreign companies. And then basically, we are, what can I say, planning how we can have the foreign companies, how we can design all the details of the Grand Challenge for now through the research project, and it was getting started from last September to next year September. So 1 year research for the preparation of the KUM Grand Challenge, and in this research we are gonna study how we can have the foreign companies. So I cannot say the details of the cooperation yet, but we are developing and then maybe in the middle of next year, we are gonna publish the result, and then we are gonna open the, what can I say? We are gonna show how holding companies can participate. But for now, I can say that we are just open for the foreign companies to take part in, and yeah, we have to figure out the details.
Okay, thank you so much.
Yeah.
Thanks for asking question, Joseph. I'm looking for any questions from attendees. If you have any question, please let me know. You could type in your question in the chat box. Mr. Yi, I have a question for you. You know, the theme of this symposium is hydrogen technology and UA, urban air mobility. And what do you think about the possibilities and prospects of using hydrogen technology for you?
Yeah, actually, right. In the roadmap, there were some aspects from the what can I say, hydrogen energy use too. So everybody might know that the limitations of eVTOL. So battery capacities is very limited for now, and even by 2003 or 2025, there is some questions about that. Yeah, so still, so some of the Korean companies are developing. I can say it is just cargo drones, but they are suggesting the use of hydrogen energy by the source of VTOL vehicles. So that's the reason why we have Doosan in the Team Korea. So we are open to use various sources of energies. But anyway, I think that we can do it because in general, we are putting a lot of steps to have hydrogen economy in Korea, especially for the auto vehicles, but all the infrastructures for the recharging and MRO capacities can help UAM hydrogen energy too. So in general, we don't exclude the use of hydrogen energy in UAM business too. We are open to do that, but we have to figure it out, especially for the recharging on the regulation for the multi-ports. It can be very crucial what kind of requirement we are going to ask for the private sector. But frankly speaking, the main focus of the UAM business was eVTOL, so electricity resources, but energy resources. But anyway, we don't exclude the use of hydrogen energy too. And then the Ministry of, what can I say? The Ministry of Trade, Industry and Energy is doing some research and development project, developing the hydrogen energy uses too. So we'll see what will happen. But anyway, that's all I can say for now, I think.
Thank you. I'm waiting for any questions from floor. Someone sent me a note. Okay. I just received a question. Let me read you question. Could you tell more details about the international collaboration like FAA, NASA, and
okay.
EASA?
Yeah. Okay. So as you know, FAA is Civil Aviation authority in the United States, and EASA is the same entity in European companies, European Union, EU. So those are two, what can I say, dominant civil aviation authority in the world, I think. First of all, regarding FAA, I think they are pretty open for the cooperation with international players, including Korea and other countries. So we are doing the bi-monthly meeting on a regular basis, and they share us a lot of good information about UAS and UAM, any kind of good recent policies and research and development projects results. So we can get updated almost real time with them. And then we suggest we share them our experience too on the meeting. So for example, we presented our UAM roadmap and Team Korea plan to them, and they were very excited about it, I think, because Korea was the first country that announced the roadmap in this area from the governmental level and suggested the specific goal to have the service by specific year. So anyway, we are, I cannot reveal the very details of it, but we are having the bi-monthly meeting with FAA. And when it comes to the EASA, lately we have the high-level meeting with the head of EASA and Deputy Minister of Aviation in Mollit. And then in that meeting, both of the parties agreed on that we already have a MOU in the civil aviation area, and we agreed to have new chapter for the new annex for the cooperation regarding UAS and UAM. So in the long run, in the future, in near future, we are gonna figure it out what can be the details of cooperation. So with the EASA, we are developing the level of cooperation for now too. So there are lots of stuff going on for the cooperation with FAA and EASA. Okay, I can say like this.
Thank you. The question is a little more specific. The question follows like this. What would be the goals of collaboration? For example, would it be information exchange or field test or evaluation?
Everything. So I think that UTM can be a good point to have collaboration. So FAA and NASA already developed and are testing a lot of stuff regarding their UTM system. And EASA is developing their own U-Space system, which is equivalent to UTM system in the United States. So, and then we are developing our own UTM system, which is called K-drone system. So I think that we can test together, or we can share the specification of the system, details of this system together. And then I think that we are open to have any kind of cooperation with KUAM Grand Challenge too, the designs of the KUAM Grand Challenge, because we have a kind of insight from the NASA's national campaign. Yeah, that can be very helpful for any kind of cooperation. And any kind of cooperation besides the government level, the industry level or academia level can have their own cooperation with their counterparts in the United States and in the European countries.
Okay, thank you. If you have any
Yeah,
question,
welcome.
please let us know. Earlier you said you're gonna develop, you're gonna host intergovernmental conference. Do you have any specific plan for the conference?
You mean the government level?
Yeah, government level conference.
Yeah, actually, we don't have any plan for this year, but next year we are gonna have it, and then we are gonna invite various countries like United States and a lot of countries from European Union, and then maybe China, yeah, and so on. But I don't have any kind of details about it, but we secured some budget for the conference, so we have to what can I say, make the details of the conference for next year, maybe in the early of next year, maybe first quarter of next year, I think.
Good. Thank you. If I do not hear any question from attendees, anybody have a question? Please let us know. Okay, hearing none.
I think your question was good enough.
Yeah, I think so.
You are a great questioner.
Thank you. I'd like to close the first panel discussion. Thank you, Mr. Lee, for your presentation. We learned a lot about the Korean government lead about developing urban air mobility. I'd like to move on to next panel.
민 교수님?
Yes. Yes.
네, 지금 세컨 타임이 패널 디스커션 다음으로 미뤄져야 될 것 같아요. 그분이 3시 반 이후에나 가능합니다.
네, 알겠습니다.
네.
I was just told that the second panel speaker is not ready yet. So I'd like to move on to the following part, which is panel session 2. The topic of this panel discussion is UAM services with hydrogen eVTOL. We have speakers. Let me check. We have Daniel McLean is here, and we have Steve Hanvey, and
Yes,
we have
here.
Ilya. All three of speakers joined our symposium. I welcome all of you. Let me get started with Steve. Steve, I'd like to introduce Steve. Steve is the president of HS Diversified Solutions. He was the former president of and CEO of Alakai Technologies. Steve, can you hear me?
Yes, can you hear me
Yes.
okay?
Yeah.
Yes.
We have a slide to show. Yeah, please share your slide.
Yes, I have about 20 minutes of slides.
Yeah, please.
Okay. And let me bring up the presentation. Can you see that okay?
Yeah, okay.
So hello from South Carolina in the United States. Here it's late evening. My presentation is maybe a little different than some of the other folks might do. I have no direct affiliation with any company right now except my own company. But I have a perspective that's based, if you look at some of the aircraft that I've worked on and projects on the right side of this that have been the precursors to the urban air mobility, which is now called advanced air mobility by NASA, and my recent experience with hydrogen with a multi-copter. So what I want to talk about is what do we need to do to bring the hydrogen-based eVTOLs forward as quickly as possible. So there's a couple of things. We don't have aviation capable pure hydrogen fuel cell based propulsion at this time. It's can't lift the amount that's needed. It is okay for the smaller drones and for the very limited flight times, but the hydrogen fuel cells that have been developed and used for the last 50 years were for different markets, not for aviation markets where you had a payload of 4 to 5 passengers. The fuel cell companies are going down the pathway that many technology companies have of developing it on their own, such as the amount of voltage or current, the connecting points, the balance of plant. So I believe we need pre-competitive standards with these companies working together where it doesn't affect their intellectual property. And I don't believe there's going to be one quote winner in here. It's good we have several presenters here of different aspects, pure hydrogen driven for existing airplanes to brand new concept aircraft. And I think it's going to be a mix of battery and ultimately hydrogen. And I think what hydrogen offers is it is the big catalyst because of its energy, which we all know. And I'll talk about that a little bit. So I think that'll be the enormous growth over the next several decades. And it is because of that that the large numbers that you see can really be affected. It will be much more difficult, in my opinion, with just pure battery. And since I'm making predictions, I wanted to bring myself back down to the earth and say, these predictions are very large, but we have to be careful how we take predictions. Henry Ford's lawyer back in 1903 told him, don't invest in Ford Motor Company. Obviously not a good recommendation. And Lord Kelvin, who is famous for our temperature scales, obviously, and 23 degrees Kelvin is important for liquid hydrogen. He said in 1895, heavier than air flying machines won't happen. And of course, 15 years later, the Wright brothers flew, and we're still trying to figure out how to get anti-gravity machines going. So having that background, let me jump ahead to looking backwards about what's happened since the mid-90s. There was a program called AGAT, Advanced General Aviation Transportation Experiment, and Small Aircraft Transportation System that NASA funded, 2 5-year programs. And its purpose was no different than what we're trying to do today, which is to fix the gridlock in the mid-90s, which is even worse today in the major cities. And how do we connect the various modes of travel to minimize door-to-door time? Well, the answer at that time was going to be the very light jets, and Dayjet was the leader.
Steve,
That,
excuse me.
yes.
Yeah, can you share us your slides?
I'm sorry?
Yeah, can you share us your slides? We cannot see your slides.
Oh my goodness. Oh, I'm sorry. I am so sorry. Let me come back. Now, oh, I'm sorry. I thought everybody said they could see them, and I made the mistake. My mistake.
It's okay. Yeah, it's good.
Yes, let me go back and just step through the first couple of slides so you can see what I was talking about as well. I'm going to stop the share and then come back up again. I'm so sorry here. Just one second. All right, can you see the screen now? See the slides?
Yes, we can.
So real quick summary, and I apologize for the delay. I summarized in the first slide, these are some of the programs that I've worked on the right side, and the four main points that I'm it's my personal perspective on what we need to do to move from the urban air mobility status of where we are today to a full hydrogen eVTOL approach. So that's the purpose of the first slide. And secondly, since I was making a prediction, I showed Henry Ford in his car in 1903 and the predictions that were made about him and Lord Kelvin and then the Jetsons. I believe this is where we caught up, where I was speaking of the mid 90s, there was gridlock and NASA came up with two programs to advance personal air transportation, personal air mobility. The very light jets, such as Dayjet proposed, was supposed to be the big winner, and that was going to make the personal mobility a reality by 2000. The SR-22 was a output program that started about 2000 under the Agate program, and that aircraft under Cirrus Aircraft, I had 26 of those aircraft in a company I started called Sats Air and others. Well, what we had gone through this Gartner hype cycle where we were just starting up. How do you do that? And this was back in 2005 to 2010. This is intended to look at where are we now with the hydrogen and the eVTOLs. And so if you look out to where we think we are right now, we're trying to get back up to the first movers. Uber and Lyft have done a fabulous job of raising the awareness of everybody about what personal air transportation can do as you move between different parts of a city. And we have electric and hydrogen powered cars that are starting to come out. One of the questions is, how do we get the infrastructure there? How do we refuel them so it's standard? Terrafugia tried to come out with a car. It's going through several iterations, and that's been for 15 years. And now we have over 300 entities that are trying to do versions of eVTOL or electric powered vehicles to replace our current systems from small to very large. So the question I ask is it real with hydrogen, and what part will it play? I think it'll play a very large part. So based on that, here's where I think we are today in the eVTOL and with the hydrogen base, but really with eVTOL for all of them. We have just a couple of first movers. The problem is the technology readiness levels, and I'll show that in the next slide, as NASA defines them, are still in the R&D level for aviation applications for the size aircraft we need to carry 2 to 5 personnel or to go a longer range than the current batteries can do. Standards are needed for both the fuel cells, the power modules, so that we can be not dependent on one company's standards like we've been in the past. And I use the example of all the different connectors you have for USB. For one connector, you might have to have multiple. We'd like to have a standard developed. We also need standards for vertiports and heliports. We know what it is for current rotorcraft, but we need to come up with simple standards because it becomes more personal transportation. I have an extensive rotorcraft background as well as fixed wing, and I've landed in a lot of really strange places in rotorcraft that were very, very small. They don't have to be a published airport. They don't have to be a large real estate development. So that infrastructure is very important in terms of how we set the standards and how simple we can keep it. So I believe we need pre-competitive standards for hydrogen due to the technology readiness level and standards for the infrastructure. So this is where, again, this is my personal opinion. We need to be up here to go into full certification and production. technology readiness levels of 8 and 9. And we need to be in certification in this level here in 6 to 8. But right now, the main areas of liquid fuel cells or even gas fuel cells, liquid fuel tanks and gaseous tanks, as well as all the fuel cells, the way we use the heat that comes out when we generate the electricity and the cooling with liquid tanks or even the intermediate pressure tanks, those are still down in the component development level and have not come at high volume capable companies yet. They know it's coming. They know what they need to do. And I'm going to talk about that a little bit. So that's a holdup. And we have to have these progression through these TR levels before we're really ready. And that generates the time and the dollars needed to bring it to full fruition as a viable customer entity. What I did is I took various public sources of fixed wing aircraft, from large ones, airliners, down to small ones, general aviation airplanes, and looked at a percentage of the total weight of the maximum gross weight for the operating empty weight, which is the structures plus pilot, how much fuel you have you're capable of flying, and therefore what payload do you have left. And if you look, you can see that the trend from airliners that are carrying lots of people, as you go through to small airplanes, it goes up slightly. The amount of fuel goes down. And then when you get into helicopters and the rotorcraft, the weight of the payload goes up as a percent. This is because the percent of empty weight goes down, and you can see that the weight of the fuel is staying down here. Well, when we get to the third category, which is for the eVTOLs, the battery eVTOLs and a hydrogen eVTOL, you can see there's a very small percentage in the hydrogen of fuel compared to any of the previous aviation. And there's no fuel, if you would, for the batteries, but that affects the payload that you have available. And that's because it's driving the empty weight up. So kind of as a gross generalization, for a liquid hydrogen fuel cell eVTOL, the mass fraction of its gross weight is probably going to be up close to 80% for a 30% payload of whatever that gross weight is, when you have basically close to zero in terms of the fuel. You're carrying your fuel with you, your energy all the time. This may seem obvious to everybody, but as the gross weight increases, the size and complexity drive that gross weight. And the batteries right now just can't carry quite enough energy. So having looked at all of that, I look back at general aviation. We started out with a piston engine with lots of parts, radial engines with lots of pistons to generate the power we needed. And then in the 1950 and 1960, we moved into the turbojet. The parts were simpler, but it burned a lot of fuel. And over time, we transitioned to the turbofan for the turboprop, the turbo shaft, and the turbofan used in general aviation airplanes with a prop, without a prop, and the shaft used in a lot of the rotorcraft. And the technology came from the inner parts of the engine that was being used and how they used the fan to take advantage of the exhaust. Well, at this point, and I'm not advocating for any given fuel cell company, the balance of plant, all the connections you have are very important. They drive the weight in the fuel cells. Some companies have started out fairly complex, and then they've gone down and become a lot smaller, but their amount of kilowatts per kilogram is very low compared to what's needed to carry 2 to 5 passengers. That's the challenge we have. Again, I'm not advocating for High Point, but they've done a very interesting evaluation of something different than the rest of the fuel cell companies have. The main large fuel cell companies are doing. And that's, they're putting high temperature instead of low temperature fuel cells. So the air quality maybe doesn't have to be quite as good. And they're using an air cooling to potentially offer the efficiency and cost and increased kilowatts per kilogram, as shown here with the growth they're showing that they can get in specific power and energy density, and more important, and just as importantly, the cost. So this is the type of thought process that we need in the industry to move out of that R&D into the technology readiness levels for certification and production at a gross weight level that will allow us to carry passengers safely. And we'll transition to the landing spots. Again, Uber and Lyft and others have done a fabulous job of putting energy into the eVTOL thought process for the last 5+ years. And Uber themselves have done great on personal transportation as they've changed the way you arrive at airports and travel within cities. However, I will take the position that having this many airport operations, particularly here, where they envision 1,000 operations an hour to be able to support a city, a large city, is not the right thought process. This is no different than the airports, where the limitation is the runways, and we can only have so many airport landings per minute in good weather, and it's reduced in bad weather. It's very interesting to think that we would take big places like this and develop them, but it takes 5 to 10 years to typically develop an airport and that infrastructure. Uber's conference in 2018, the head of public works for Los Angeles, who's responsible for the electrical power into the Los Angeles basin, said that to do this type of operation and the operations that Uber's envisioning for Los Angeles would equal the amount of electricity that currently runs the entire grid for Los Angeles. And as you know, during hot times, they sometimes have brownouts. So I question that that's the right approach to have us get there as fast as we can. Instead, I argue that we have a lot of space, of real estate today in parking lots, sports venues, vertical parking lots, and small innovative concepts like SkyDrive has done, and powered by hydrogen, although it's by battery today, can utilize a very small percentage of this parking lot. And that's where the vertiport standards need to come from. The reason I say that is there's an infinite combination of going from parking lots to personal homes, to sports venues, to schools, to businesses that don't have to go to a central location with these large real estate. And there's creative ways in certain parts of the world where you can have combined modal transportation and you can land a small vehicle by creating the right landing space. This is not as big a real estate play as it is in the major cities. When I ran the company Sats Air with 26 SR-22s, we landed on an annual basis in 500 airports. That same area only has 35 regional airports and only 5 major airports that have the large airplanes. So we had a large number of operations that could be done very close to where one's office or home was. And that gave people a personal control of their transportation. And I think that's what the basis of urban air mobility and advanced air mobility will become as it fully develops over the next couple of years. We're familiar with hydrogen energy relative to batteries, but I just wanted to highlight it has so much specific energy here that there are people that prognosticate and have a diversity of opinions on cost requirements and what is really the bottom line efficiency when you look at transportation cost and heat losses and other things that go from battery versus hydrogen versus internal combustion. Some people think the battery gives you the best overall efficiency. It's not the cleanest because we have a lot of recycled cost. So that's probably closer to 60% at the best. Whereas in hydrogen, if we do co-location with wind and solar or find ways to break through in electrolysis, close to the source, that number can go up significantly. And maybe it's closer to 50%. And then when we look at the heat recovery, when you generate the electricity with a fuel cell and the cooling that you get out of liquid when it goes to gas, you can recover maybe 40%. So that number may be closer to 60%, putting batteries and hydrogen about the same, but they're still much heavier here. We have to have the infrastructure developed. So there's diversity of opinions about how much does it cost to go from here in solar through the processing and the transportation to ultimately get it here. And the cost of hydrogen at $12 to $15 per kilogram needs to come down below $5 per kilogram. And that can happen by putting some R&D into this area as well. These are examples. Again, I'm not advocating for any particular fuel cell company, but there's been a standard that SAE has done that's been accepted worldwide for hydrogen station standards. We need to come up with a standard how we connect together to put in whether it's gas or liquid hydrogen. In the same manner I showed the connections for the USB at the beginning. But you can see the balance of plant is different at different manufacturers. And we ought to standardize that, because where the individual fuel cell companies can make their money is in getting low cost balance of plant to some standard through these areas up here. And this is where the real frontier is. We know that hydrogen generates about 1.4 volts of electricity, but we're only able to use about 0.6 of it today. And maybe we can get up to 0.7 by the way we introduce the hydrogen in the flow fields within the fuel cells. And just an increase from 0.6 to 0.7 would represent a 15% improvement in power and fuel consumption. So I don't think there'll be one winner, as I said earlier. I think it'll be a combination. Out of those 300, there'll emerge 10 or 15 companies that will truly plot the future for eVTOLs, and it'll be complementary. Aviation Week in Space made a comparison of the different types of vehicles, cargo, personal, lift crews, multi-copters, and vectored thrust, and how many people are back here in the concept technology area. This is the low technology readiness levels that NASA talks about. There's only less than 5 that have gotten out here where they're doing things with battery and trying to make commercialization happen, such as EHang and Kitty Hawk right now, where Beta is and Joby are, and Boeing, and where the FAA sees some of these programs. So we're going to have a migration, and I showed it on purpose, from lower size, lower complexity, lower cost, lower technology, lower weight to the higher ones. And ultimately, maybe we'll get to the anti-gravity. But this causes us to increase the direct operating cost as we get more complex, as we get heavier. And the acquisition cost goes up. And I might add, that's for the personal air transportation. As we do it for regional transportation and come up with those concepts, I haven't addressed that specifically here. As you get more passengers in the vehicle, then obviously the cost can come down. There's been an estimate by Roland Berger back in July in the Global Urban Air Summit, The Future of UAM, that 7,000 eVTOL aircraft will be carrying passengers by 2030 and almost 50,000 by 2040, and continues to go up. That 36% of them will be air taxis within a city. 35% of them will be shuttles for the airports. And all these are low ranges below 30 miles. And 30% will be between cities. This says there's a large diversity of attention to what's important. And the more we can come together on which are the important characteristics of eVTOL, I think the faster we'll realize that full potential, because the market is out there. I saw that in my air taxi company when I started offering personal transportation from a large number of locations. So again, what we're seeing is as we transition from battery through hydrogen, and when we go to hybrids of lift and propulsion, that's the way we get the increased range and payload. And this is just miles of range as a rough estimate that it increases. And we can trade here for some range and payload depending upon what market you're trying to address. These are estimates made from other people. Morgan Stanley did an analyzed article back in 2019, just one of many studies showing the worldwide growth in Europe, in China, the US, and the rest of the world. And you can see that they're projecting fairly flat, and then it really takes off in not this decade, but the next decade. That's the exponential growth. And there's growth in all the cities projected across the world. This is how we recognize this total economy. So I believe that vision's real, and I believe that timetable out here is probably closer than what some of the early projections are for right here. This might be flatter, and then it's going to be steeper. And hydrogen is going to play an enormous, in my opinion, part of the rate at which that grows. And I do this based on history. This was a presentation done in 1999 by Dr. Bruce Holmes on what is the impact of speed over time as we move from cars, from horses being replaced by cars, and the speed gradually came up. What was important was how fast you went from the door of your house to another house, or the door to your business to another business. And as we did this, people started moving to different locations as well. They moved out of the cities into the suburbs. And then after the airlines started coming in, aircraft that could carry more than a few people, in the 30s, we saw props being the main displacement for cars for going longer distances. And ultimately in the 50s and 60s, with the turbojet and the turbofan, it started to transition where jetliners started replacing the props, longer distances for similar door-to-door speeds. And then in this part is where the NASA program came, and GPS and other technologies here, general aviation propulsion machines that had very high efficiencies, started us up this cycle for the small aircraft transportation system, which today we call the urban air mobility. And you can see that in 1999 was projected to get flat by where we are right now in 2020, but it didn't happen because those VLJs never came to fruition. It wasn't a large enough volume. And so eVTOLs came in with all that we understand about the UAM, AAM market projections right now. Again, this was done 20 years ago. And Dr. Holmes also made a second assessment of the movement of people, looking back for 2 centuries, that people have moved from farms to the city, from the city to the suburbs, and now from the cities, and this was for American market, but this is out of the big cities. And you can see he made this projection in 1998 of what he thought would happen right here where we are now, of people starting to move out of the suburbs to rural America. But it's true throughout the world. COVID-19 has certainly made an impact on that. The personal computer, the ability to work from locations, to have a virtual conference like we are today, affects where we can work. And so that will affect, I believe, the market and how well we do with that market. Again, there's a lot of competition out here. I highlighted the one hydrogen that I worked on, the Sky vehicle. This was done by Competition Magazine, showing all the various competitors. And again, they all have barriers, but I think we start down here at the bottom with social and safety. If it's not safe and there's not acceptance by the general public, it'll never go anywhere. It needs to have a value proposition and economics that are good. We have to have the infrastructure in there to make it grow, and it has to meet the standards of the various countries, EASA, FAA, and the other standards like Korea's talking about developing, and we need the technology to do that. All those are their own form of barriers. So we have visions, as was presented earlier by Mr. Rang, but what part will hydrogen play? And I think hydrogen has the most potential as I've stated. And I'm not biased on that because I've come from a different environment. I've come from the regular aircraft industry. So I'll close by saying, again, we have to have capable, aviation capable of carrying a large enough payload, which is probably 4,000 pounds of total empty weight, of total aircraft weight, to carry the passengers to make this economical. We need to work together on the fuel cells. We need to have a plan that doesn't say there's going to be one winner. There's going to be multiple winners to have the growth over the next 2 to 3 decades. And hydrogen should provide that way to grow. And I think vehicles like Sky and hybrids will make that growth happen because the fundamentals of the physics have never changed. We have to lift our structure. We have to lift our payload. We want to go a certain distance and we got to overcome that drag. And that doesn't change, doesn't matter what you put together, but the bigger it is, the more complex it is, the more it costs. And that's what we have to do. So that's my personal opinion, my perspective on 40 years of developing and certifying aircraft. And in very poor Korean, I will say 감사합니다.
Thank you. Excellent presentation, Steve. Thanks for your giving overview of technology and the market. Let me check the current status of this symposium. We were supposed to have a panel discussion, the first panel session, but the speaker wasn't available.
Phil is here.
Okay, you know what I think? I propose we go back to the panel 1 session because Val is in England, if I know correctly. Considering his time zone, I think I'd like to propose that we go back to panel session 1, and then we come back to panel session 2. What do you think? Val, are you ready?
Yeah, this is Val. I'm actually in California, so if you want to continue with panel 2, that's fine, and then I will join in. Okay, then thank you. Thanks for your understanding. Then why don't we just finish the panel session 2? Next speaker in this panel is Daniel McLean, CEO of Happy Takeoff. Daniel, are you ready?
Yeah, we are ready. I'm here with Rachel Locks. Hi. She's our COO. Yeah, thanks so much, guys. Thank you, Joe, for inviting us and everybody for participating. Really enjoyed, Steve, your presentation. We talk with Bruce Holmes often, so it's nice to finally be engaged with you. And we couldn't agree with everything that you said more. Just spot on with everything. So there'll probably be some repeated information. I'm glad that you went into more of the technical side of it. Ours is pretty high level. With that said, here is our aircraft, Prism. It's the first eVTOL hydrogen fuel cell with the fixed wing. We thought that was really important going into this space. Yes, I agree with Steve that there will be multiple winners, and even on the ride sharing side of things, Uber might not be the winner, although they've done a great job of getting the public to be aware of this. But we wanted to have that option to partner with them, and they've made it really clear that they wouldn't partner with companies that didn't have a wing. So having a wing just added that extra level of safety. And can we go to the next slide? Yeah, cool. So a lot of you probably are familiar with these numbers. Won't spend too much time on this slide, but in the US, we lost 300 billion in 2018 just from sitting in traffic. And then back to Uber Elevate. So Uber released some requirements, I think in like 2018 or 19, of what they would like to see for their charging times and ranges and things like that. So about 7 minutes charge time. If you're looking at a battery powered eVTOL, that's going to be very difficult to achieve. We've heard of some, rapid charging batteries coming online, but we don't see them getting to these fast charge times in the projected timeline that Uber wants to see. Further, the range 60 miles, there are people that can do that, but we just feel like we can do better. Let's make a longer range and let's create a way that we can charge them or refuel them quickly. This kind of goes over what Uber said they need. That top row shows you the energy density, specific power charge time. What Uber wants, that charge time was 7 minutes. We just rounded it to 10. And then where current lithium ion technology is. So the energy density looks really good, but the specific power does not. And oh, I'm sorry. Yeah, I said that backwards. Yeah, the energy density does not look good and the specific power does. And so, yeah, I was thinking of hydrogen when I was saying that. Sorry, I said that backwards. And so just like Steve was saying, the idea is basically to use batteries for the takeoff and landing. We don't see hydrogen being able to do that right now. And to be honest, don't even see a path to get to that. That would be an interesting area for somebody to look into. So we see the batteries, because that takeoff, that's where you're really drawing a lot of power quickly. And so you're going to use batteries for your takeoff and landing, basically your vertical operations. And then when you go into cruise, that's when you can use hydrogen. And if you use hydrogen for your cruise instead of batteries, then you can really extend that range. And that's why you see that the hydrogen eVTOLs, are having 200 to 300 mile ranges versus the battery ones are, 50, 60 miles. Some of them say 120. I'm skeptical. And, a lot of people have speculated that because you need, because of those long charging times with your lithium ion batteries, you would need 2 charging for every one that's in the air. And I saw that Ilya was on this, this symposium, and I think he talks to this even better in his presentation. So I'm hoping we'll hear more about this. But so how that translates is you basically have 2 aircraft that aren't making you any money. And in aerospace, that's typically you learn safety first, and then next is a grounded airplane is a poor airplane. It's not bringing in any income, and that's not good for business at all. And so, we're kind of looking at, all right, how can we, reduce these charge times? It's something to really think about. And let you talk to this one.
Yeah, so in addition to the charging times, the infrastructure demand with limited flight ranges of 60 miles, this slide kind of illustrates how the infrastructure demands are affected by that limited flight range. So on the left side, we assume that we're using an aircraft with lithium ion technology. So we give them, like we mentioned, that 60-mile flight range. We calculated that you would need a total of 8 stations to make the trip from San Francisco to Los Angeles. We just chose that as an example because it's of high interest due to traffic. So we used the cost of $2 million because that's kind of what we've been seeing so far for prototypes and their projected cost.
For infrastructure.
For infrastructure, right. So that puts the total investment to implement this infrastructure at $16 million. Conversely, if you were to use a hydrogen fuel cell vehicle with a flight range of 250 miles, which we're shooting for that goal with our aircraft Prism, I believe Valwa Zero Avia is looking at double that. So the flight range, it makes a huge difference in terms of the cost of infrastructure. So we estimated that 3.5 million would be roughly the cost. That's kind of a target goal that we're working towards. So even though it costs more per station, you're installing 3 versus 8. So the total cost is significantly less than it would be with lithium ion infrastructure.
Yeah, so so this slide goes into, and please, if you have any questions on this slide, I think this is one of our most important slides that we have, but I've had a difficult time really kind of driving this home. So any questions that you have on this slide, send them in the chat. I want to make sure that I get this message across. So as I showed you that slide a few minutes ago, where it showed 2 charging. Yeah, exactly. So these 2 charging on the ground, well, you had to manufacture those. So you basically had to manufacture 3 aircraft just to get one of them in the air. And so what we're looking at on the right, where you're seeing these cost savings, we're looking at it not only from the money. So the other slide was looking at the money you're going to lose by the aircraft being grounded, but this is the extra money that you're going to spend in your manufacturing fleet costs just by having to produce those 3 aircraft. And the calculation that I used, I mean, is really basic. So I have a few years experience in aerospace manufacturing here in Wichita, where we're the aerospace manufacturing capital of the world. And so I guess some of this to me seems like common knowledge, but it probably isn't. But where if you're looking at a composite airframe, which, and this is an opinion, but I feel like it's the way to go. Because if you get into like an aluminum airframe, then corrosion becomes a really big problem. And the chemicals that you have to put on the aluminum to keep it from corroding are extremely toxic. Hexavalent chrome is the main one. And a lot of countries, and especially REACH, which is in Europe, and EASA are starting to look towards banning any kind of hexavalent chrome. So we just really want to stay away from that, especially if you're in regions that are near the water, where because the salt is what causes those metals to corrode. So looking at it from a composite standpoint, that's what these numbers are based off. If you say we're going to make 10,000 airframes, which is a number I got just from Mark Moore talking at his their Uber Elevate events. They say we'll need 10,000 of these aircraft at 4,000 pounds each. That's just I feel like kind of a safe sort of in the middle number. Our aircraft weighs much more than 4,000, but just to show you the calculation, we're using a 4,000 pound airframe at $50 per pound. So that $50 per pound is what a lot of aircraft OEMs, a lot of the eVTOL OEMs are targeting as their manufacturing cost for building an airframe. And I want to tell you that is a very, currently a very unrealistic number. Often you'll hear composite people say, well, we can do aerospace composites for $10 a pound, but that's like just the raw materials. After you produce it, a lot of it, you know, with the complexity of doing a composite part, if you're doing hand layup, or it's tedious, and it takes a lot of man hours to put into that. So you're going to end up having probably closer to around 250 pounds or $250 per pound. But for the sake of simplicity, I used $50 per pound. So if it was 10,000 aircraft, multiply that times 4,000 pounds, multiply that times $50, that's where that number came from. You end up saving 1.3 billion just on your manufacturing. The point of that is you're going to actually save a lot more unless somebody figures out a way to completely automate a composites factory, which I haven't seen yet, but this also is a reason why we really need the automotive industry to get involved in this space with us. So if any of that wasn't clear, please ask me a question, because I think this is a really important benefit to hydrogen. So this is just kind of overview of what we're going to cover next. So the lack of infrastructure in the United States is a big challenge for hydrogen. What you see on this map is pretty much what you get. There's about 40 in California, and they're pretty much non-existent anywhere else in the United States. We would need to change that. And this is for cars, this is for automobiles. But we can learn from what they've done. And then United States versus other countries, just looking at the infrastructure for hydrogen refueling stations in automotive. That's all we're looking at here. This isn't even looking at aerospace. At the bottom, at the 2020 range, everybody looks pretty even. If you zoom into that, we can't on here, but if you were to zoom in, the United States is a little bit further behind. Japan is leading, but you can see that Europe in 2030 has And there's been all kinds of stuff in the news lately that they intend to be the leader. So, you know, we need to step up our game if we want to be competitive in that space. This just says the same thing that the last slide did in concrete numbers. So like if you look at right now, the United States has 40 hydrogen refueling stations, and they're trying to have 1,000 by 2030. You look at Europe, they've got 152, and they want to boost that all the way up to 3,700. So the majority of the hydrogen refueling stations would be in Europe in 2030. Again, key takeaway, we need to step our game up. So this is our vision. We really feel like the reason why we've included the automotive infrastructure for hydrogen in the previous slides is because we sort of see a vision like this, where if you've seen what Nikola Motors is doing with their heavy duty trucks, the power demands for those trucks are very similar to what we would need in our aircraft. And so we don't see any reason why we can't share that infrastructure. One of the downsides of hydrogen is that it's expensive. One of the things that makes it expensive is the transport cost of the hydrogen. So we believe if we make the hydrogen at or very near to the location where it's going to be used, you can eliminate a lot of those costs. And then also using as much renewable sources as you can to produce that hydrogen. And so again, this just sort of repeats what we had in our last slide in a 2D version. I really like what Steve said about, you know, the Uber Elevate concept of infrastructure is just really not feasible. I think he mentioned that at the Uber Elevate conference, I think it was the mayor of LA said that it wasn't feasible. And we actually went to the city of Los Angeles and talked to a lot of them. And not only did they not think it was feasible, they didn't really like the idea of having all of these, you know, landing locations on top of rooftops. I know it makes for some really cool pictures for NASA, but it would be very difficult. They felt like it would be very difficult sell to the public. You know, how do we sell this as something people are going to want? And further, has anybody even talked to these building owners? Who's going to pay for that power? And even if you were to consider using renewables, you just don't have enough real estate on those rooftops to really do anything meaningful. So we don't really see that as being a path forward. Like the parking garage idea, also like kind of rural ideas. And then we'll kind of go into public perception.
Yeah, so public perception of safety, a lot of people we found, the first thing they think about when we speak of aircrafts powered by hydrogen is the Hindenburg, which I don't know how well known this is internationally, but here in the US, it was an event that happened in 1937. It happened right around the time that that video camera technology was allowing people to record these type of events and share them with the world. And so this disaster, the Hindenburg, was an aircraft that was actually designed to use helium, which is much less combustible than hydrogen. But due to the kind of geopolitical climate in pre-World War II era, there was no helium available for Germany to use to fill this dirigible. So they ended up filling it with hydrogen, and then it ended up crashing basically when it was coming in to land in New Jersey. It was caught on film. It was seen by everyone, and the effect still lingers today. And so it's definitely affected the public perception of how hydrogen, how safe it is to use in aircraft, especially. Did you make this?
Yeah, this is just a pretty slide, but that's the key takeaway.
Yeah. Yeah, and to go further on the Hindenburg disaster, after the disaster happened, there was a two-country kind of coalition investigative task force that looked into the cause of it, and they believed that it, when the dirigible was coming into port in New Jersey, it turned too sharply. It caused one of the hydrogen fuel cells to break open and start leaking hydrogen into the atmosphere. And then when they dropped the mooring ropes to connect to the winch, it was raining that day. And so it grounded and allowed a static spark. And there was a lot of energy saved up from the trip across the Atlantic. So it just kind of set it off. Today, we're using much more advanced and much safer technologies. So this is, again, Prism. This is our baby. This is currently in the conceptual phase. We are working hard to get our first scaled prototype made, which would be what, 1/3, not even 1/3. It's a small scale model that we're going to use to just kind of do some testing, some flight testing, and get some miles on there. Our goal is to have zero emissions, which means we have to get completely free of fossil fuels to produce hydrogen fuel. We think it kind of defeats the purpose to produce hydrogen using fossil fuels. Our goal is to hit a 250-mile range. Like Steven said, some of our friends over at High Point, for example, again, not necessarily advocating that for High Point, but they're our friends and we like what they're doing. We are hoping that we can actually even surpass that 250 miles flight range. So refueling time, we're hoping to be around 10 minutes. It's going to be much faster than recharging. And we're looking at having a 1,200-pound payload, which would be roughly 6 passengers if you chose to go with the passenger configuration. Our aircraft was designed by Daryl Cummings. He is one of our favorite designers. We think he's one of the best in the world. He designed it to be safe and to also fulfill the requirements of both Uber Elevate and the US military. So the design, it has folding wings, which makes a very small footprint, so you can fit a lot in a small space. The initial design is going to be capable of using AV gas, but the plan is to eventually switch over to a hydrogen powertrain. The AV gas would be used for potentially certification purposes only. So we have a fixed wing. We're the only aircraft we know of that's powered by hydrogen and also capable of vertical takeoff and landing and has a fixed wing. So we think that's kind of our niche that we found. And it's like Steven said, we don't think it's going to be one winner. We think it's going to be several winners. And so we tried to kind of find a niche that would complement our friends who are building aircraft as well, but that would allow us to thrive. So like we mentioned, fewer refueling stations would be necessary with hydrogen. And like we mentioned before, it's going to be a hybrid system using batteries to power the 8 vertical lift propellers that you can see there. They're stacked. They're in stacks of 2, and they're made that way as a safety redundancy feature. So if one propeller fails, then you can switch to the other set of propellers and make it safely to the next landing spot. And speaking of safety, this was another thing that was very important to us and to Daryl. We have all fixed components. We don't have tilting rotors or tilting wings, which means less parts to break and less parts to keep in stock for repairs. So we think it's not only safer, but can also improve maintenance costs. I mentioned the redundancy of the stacked motors. We have, so the fixed wing also will allow emergency landing. So if for some reason we lose both sets of vertical lift propellers, we can still glide hopefully to safety. And then we have low disc loading. So we have a low ratio of the overall propeller area to the aircraft. And what that means is there's going to be a lot less debris kicked up when we're coming in for landing or when we're taking off. We think that the best fit for us in terms of market would be in the medical field. We think that we have many advantages over current helicopters in terms of using our design for air ambulance, organ delivery, and we think it would also be very viable for patient transport for stabilized patients. We have a longer flight range compared to battery-powered eVTOLs, at least at the conceptual level. So we think that you'll be able to take the patient from point A to point B with fewer stops. we mentioned the safety and the efficiency in the last slide, but we think that's it's going to translate to better patient outcomes, that it's a safer vehicle with fewer chances to injure the patients. And then, yeah, that's kind of what I said there. So this illustrates the smaller footprints. This is compared to an F-35. So you can fit many more of these on, for example, an aircraft carrier or a landing strip. This is our team. We're very proud of our team. We feel like we have a lot of momentum going forward. I'll let Danielle talk to this.
Well, something that was really important to me in starting Happy Takeoff, which funny story, when coming up with the name Happy Takeoff, Rachel and I, one of our biggest, I should say, heroes is Nikola Tesla. And Tesla was already taken, and then Nikola Motors was taken. And it turns out Nikola Tesla doesn't have a middle name. So we went with Happy Takeoff instead. So yeah, this is our team. Me on the left, my daughter Dominique, Rachel, Daryl Cummings, our aircraft design, Dr. Jamie Jacob. He actually used to be my professor when I went to Oklahoma State, designed a hydrogen aircraft under him. Adam is our hydrogen expert here in Kansas. And then Javin Pierce, who's also got some experience in the medical industry. As Steve mentioned, there are like 300 OEMs doing this, but we're the only girls. So that is another thing that we're unique on. So we're the only woman-owned eVTOL OEM. And something that's super important to me is working in industry. You know, aerospace is one of the main industries that is not diverse enough. And while I've worked with some amazing people and I've learned a ton from the guys that I've worked with and have some amazing role models, it was discouraging at times that I didn't have any women role models. And I know there are a few out there, but they tend to be kind of overloaded because there's so few of them. And so I really wanted to kind of put myself in the position to be that for other young girls coming up in this space and other underrepresented groups. But anyway, yeah, so we have the team of experienced designers. We've also got some DER people. Those are the people that can take your aircraft from like basically concept to certification with the FAA. They have to be certified. It's not easy to get. Those people are insanely smart and talented. So we're really happy to have a team of those people working with us on the hydrogen propulsion system and taking that to certification. Our core values, we believe that the planet is first, and that's what made us go with hydrogen. We see, you know, the value in lithium, but we also see some of the downsides. One being that lithium is a finite resource. And so, you know, we want to do something that's good for the earth, good for everybody involved. You know, we don't have everything figured out with hydrogen yet, but we think that that is the way to go and that is the future. The rest of those are pretty self-explanatory. You guys probably know these numbers or you wouldn't even be in this symposium. We think that 8 billion is, that's our total obtainable market that we can look at getting right now. And we think the way to do that is through medical. The package delivery, you know, we're already seeing that happen. UPS and FedEx and Amazon are really going forward with this. And furthermore, our smaller prototype, we think will play a role in that. But we think medical is the next big leap to take to really get to that 1.5 trillion. We don't really need to spend time on this slide. If you're interested in talking dollars and investment, we can talk offline about that one. So our funding, we're currently in negotiations with some funding. As Rachel mentioned, we are working on a scaled prototype. It's about 80% complete. We applied to Agility Prime. We're still waiting to hear back. We're really hopeful about that. And we've also done a concept of our refueling station. The next 6 to 9 months will be 5.5 million, and our goals with that, I think I can actually just jump. Yeah, so this will show kind of a little bit clearer what we're looking to do. In 6 months, we want to take that scaled prototype put her in the air and start flight testing. One of the, the challenges that we're having right now is it's really hard to define exactly what system that we need. So we're sort of just putting one on it and flight testing it just to get some data to be able to know exactly what hydrogen system we'll need. And so then in 12 months, we think we'll have those answers where we can actually say, hey, this is what we need, and then have a company like, say, High Point or whoever develop it. And we welcome Sky or Alakai, I forgot which one you guys are going by now, and Zero and Bartini and all of the players in this space. This certification of this hydrogen system is not going to be an easy task. It's something that we're taking on, but we don't think that we can do it alone. And we would love to, all collaborate on that, as we see that being our biggest challenge to going forward. It kind of seems like the logistics of the infrastructure, while complicated, all of the pieces seem to be there. It's just sort of a matter of getting everybody to talk. But this certifying the hydrogen system, because the FAA kind of tends to think that we want to certify a hydrogen bomb, and obviously that's not the case. But we need to prove that, and we need to prove that with flying it and data. So yeah, we invite you to join us on that journey. As you see, our timeline only goes out to 18 months. That's because we don't know what we don't know, and with that data that we collect when we're flight testing, we'll be able to put some realistic numbers in there. But that's kind of where we see the trajectory that we're on. I'm happy to discuss more offline if you are interested. And yeah, I think that's it from us.
Thank you, Danielle. Thank you. After, we have one presenter waiting. After his talk, we're gonna have question and answers. Let me introduce Ilya Kanikov. He's the CTO of Bartini Aero Inc. Ilya, are you ready? Please turn on your.
Absolutely, yes. Absolutely. Thank you, Sam, and thank you, Daniel, for mentioning me in your presentation. As they say, great minds think alike, and I may be touching upon the same topics, and my task will be to demonstrate a few dependencies and showcase how topics we discuss intertwine so very closely. And thank you, Stefan, for putting our vehicles on your slides. It is so very insightful to analyze the vehicles as themselves, but it will be my task, and I would want to add the need to what we believe to analyze the efficiencies within larger system-wide boundaries. So I will share my slides. And I hope you see the title slide. So, dear colleagues, friends, fellow COVID detainees, thank you for being here today to discuss the future, and dealing with the present is quite challenging. However, if we stop talking about the future and working towards the future, there will be no future. And let me congratulate you on being resilient and forward-thinking. I'm Ilya Kanikov, and I'm doing this electric vertical takeoff and landing vehicle called Bartini. We are a team of passenger jet builders who were possibly the first in the industry to team up with the best automotive engineers on the planet, Ital Design, to get to you the two-seater and the four-seater, each of which will be powered by either a lithium battery or a hydrogen fuel cell. So our configuration combines the benefits of hovers and winged aircraft. So it's small footprint and flight efficiency. The wide carrying body will provide aerodynamic lift and the comfort of a spacious cabin. To that, we will add low noise from the ducted fans and the highest safety standards of civil aviation. So for us, the choice between lithium and hydrogen powertrain means much more than a choice of a component or a choice of ground handling systems. It means the choice of scalability, and it means the choice of price, and it actually means the choice of the future in which you as customers will get the service of transportation. So we call this operational perimeter. And the question is it about private owners in flying clubs or commercial operators, commercially operated massive air taxis? And we believe, as we are now transiting from ground to air, much like a century ago we transited from horses to cars, for the air taxi to happen, all peripheral systems must be ready to scale. So I'm also an advisor to the McFly Aero Infrastructure, which is a strategy think tank and consultancy for property owners. And to become a technology integrator in the future, we deal with preliminary design of the ground facilities and air traffic architecture in various parts of the world. And that is why it is our job to trace dependencies and evaluate systems interfaces across the emerging value chain. The value chain for the service of flight, that is, not for the aircraft. And I actually liked very much the slide where Stefan showed all the USB connectors, which is a great metaphor for what needs to be accomplished. So we identified challenges and we asked questions that generally relate to feasibility, compatibility, economics, and certification of different systems. And the first question for air taxis is, what will it be? What will be the systems design? So will we fly between large hubs, or there will be a multitude of small landing pads? So sky hubs or sky stops. And quite frankly, from the user perspective, what we generally want from the transportation is to be on demand, seamless, and affordable. That's what we want. We also want controlled privacy. And so far we may choose a bus, a train, a taxi, or a personal car, but we have always compromised between choosing on-demand seamlessness, affordability, or privacy. And with this in mind, for the future of aviation, we don't want to compromise. We want sky stops, not hubs. And we want them every 5-10 minute walk from any final destination. So we want them to integrate into architectural and cultural environment and perhaps serve not only as passenger, but also delivery pickup points. And our choice between lithium or hydrogen will either limit or enhance our ability to make such systems. So before we do a deeper dive, I must say that some features of the future system do not depend on powertrains, but because they quite usually raise a lot of concerns. So please let me briefly make a check on them to give you a fuller picture. So firstly, on autonomy. So we believe that ultimately there will be system-wide central airspace. System-wide central airspace routing and aircraft orientation management. It will feel like autonomy to passengers, but at the same time ensure system-wide safety and create numerous efficiencies. Piloted aircraft, where's that? May be deployed first, but even they will most likely follow strict routes and quite unlike general aviation today. And it is also our view that most likely we're quite far away from true and full autonomy on a vehicle level. So prepare to get your operator's licenses for onboard or remote piloting pretty soon. Speaking of routing, secondly, I wanted to touch upon that most likely air taxi users will not peek through your windows, as many are concerned. They will the air taxis will not fly over critical facilities on the ground. There will be flyways or on-demand flight paths, and that will be monitored and controlled through transponders. So systems like Astra UTM can already now track thousands of airspace users simultaneously, and it can handle flight requests, approvals, monitor designated airspace, perform deconfliction, and so on and so forth. So your home will most likely be surrounded by restricted airspace, much like today it is encircled by a garden. So now that we're comfortable about these two, let's get back to energy and allow me to track one chain of dependencies for you. Lithium gives 30 minutes of flight and 90 miles of range. That's San Francisco to Salinas or Monterey. Hydrogen gives 2 hours and 340 miles. And that's all the way down to Santa Monica, or all the way from Seoul to Jeju. Hydrogen unlocks travel, but then it is still 2 hours in the cabin. So to make full use of this opportunity, we must make a very comfortable cabin so that people are actually happy to spend more time in it. And also the chosen air traffic management system must cover larger areas and must be able to efficiently handle handovers. So you can see how these dependencies form. And from air to ground, hydrogen, yes, can take 10 times faster to refuel than a lithium battery to recharge. So imagine you run the clock A to B air taxi operation, and Daniel was talking about that. On lithium, 1 to 3 aircraft will need to be charging, while yet another one flies the mission. With hydrogen, only 1 aircraft will suffice. That means while the hydrogen fuel cells are still costing more, and the aircraft will cost more that will have hydrogen fuel cells on board, but you literally need 3-4 times less vehicles in your air taxi fleet. You will also avoid having your aircraft grounded, and it's good because when grounded, they don't earn money, they take valuable space, they require handling, and that's what you get. And of course, some say that soon there will be batteries that will recharge in 10 minutes, not 30 minutes. And that's fair enough. But let's then look at the required power capacity from the grid. So to charge 85 kilowatt hour battery in 10 minutes, you need half a megawatt capacity. And since you need to charge 2 or 3 while another one is flying, you actually need from 1 to 3 megawatt capacity connection. Daniel was talking about it, and you need that even per small operation. So think on that from 3 perspectives, actually. So first of all, how safe and easy will that cable be? And will that plug be? Will it be easy to connect by a human? Will it require expensive, complicated machinery to assist? What will all the maintenance and repairs cost for that? Secondly, there are other many places in your city where actually such electric capacity is available. And thirdly, can you count on that electric capacity to be extended to all those places that you would really want to visit? So every city is electrifying these days. And a lot of infrastructure investment is taking place. A lot of infrastructure investment is taking place to install those electric chargers. And yes, our lithium modification will benefit from that. But just think, what if you didn't need to connect a SkyStop to the power grid? What if we could store the energy on the landing pad by distributing hydrogen, for example, in tanks? Perhaps even using the same fleet during off-peak hours. Or better yet, what if we produce hydrogen on site using solar? And then we can have sky stops in almost any place. And that would unlock so many more destinations and will make the system so much more scalable. So the question stands, why are there not so many eVTOLs planning to use hydrogen? Well, this is not something you can easily do or switch to. So first of all, the aircraft has to be designed from the onstart to be able to use hydrogen fuel cells. The form factor is very demanding. So for example, with batteries, you could place them all over the body of the aircraft, and many designers, developers actually do that. They use batteries to balance the weights. And fuel cell and hydrogen tank are heavy and bulky. So Bartini was initially designed to use hydrogen fuel cells. As you can see, we have allocated space for it. And hydrogen fuel cell technology was not common when many of the eVTOL designs were ideated. That's another reason why they may not go for it. And still, yet today, the hydrogen technology that is now commercially available is not the one that we need. Stefan was talking about this. There is uncertainty about availability of that technology. The liquid-cooled hydrogen fuel cells, the one used in cars and buses, are too heavy. And we, the eVTOL makers, need air-cooled fuel cells, and this is a new product. We work with probably the world's leader in developing such technology, a company called High Point. I'm glad to name them again because they deserve all this credit. We have realized early on at Bartini how important it is to have more energy on board and how unlikely it would be to get it all from lithium technologies. So we made a bet that commercially available, air-cooled, high-density fuel cells are closer than higher-density batteries. And there are also other technological challenges connected to placing a hydrogen fuel cell into the craft. Such challenges include like additional structure strength, the air ducts for incoming and outgoing cooling flow of air, rearranging other peripherals that are required for the fuel cell to operate. And we should also not forget about certification of such powertrain to be used for commercial aviation. And at the same time, it was a big bet for us a few years back, but we see now a lot of traction towards hydrogen. These days, regulators are working all over the world, and we believe that embracing hydrogen will unlock the true potential of electric air travel. Yeah, another usual concern is that today the fuel cell and hydrogen itself are quite pricey. So many think that hydrogen travel will be actually more expensive than that on lithium. And after all, you can see that the mile in a hydrogen-fueled Mirai is almost 3 times more expensive than the mile in a gasoline-fueled, say, Camry. But unlike cars, there are so many more components, like I said, in the aircraft operation than just energy. Their aggregated efficiencies can be overwhelming. So, for example, you need to replace the worn-out lithium battery a few times over the life cycle of the vehicle, usually after 1,000 or 2,000 recharge cycles. And you don't need to replace a fuel cell. So summing it up, hydrogen enables the same operation with smaller fleet, and the operator will pay for less ground time per vehicle, and less maintenance and handling will be required. Sky stops can be more easily built in more locations, and hence distribution and availability of sky stops will create more demand, hence lower prices. Vehicles will have more energy on board, hence more efficient air traffic management and simpler and cheaper ground facilities. So all these together constitute important system-wide efficiencies that the hydrogen technology is able to unlock. And those considerations are beyond, far beyond just component and energy unit costs. Speaking of which, of course, we should not forget that fuel cells will only go down in price when they get to mass production, and hydrogen will cost far less when more of it will be produced using renewable energy. So we should not underestimate how the choice between hydrogen and lithium is a choice of the overall system design. And actually, this choice is being made today, as we speak, by the gravity of regulators, cities, infrastructure developers, and those choices, and let's call it the client side choices or the choices on the operator side, they drive eVTOL design. And please don't forget, it takes a while to make and certify an aircraft. So the choices that, well, if I may say, you make today, inevitably lead to product design decisions we make today, and those will stick for years. It is important to make sure that those decisions do not create unnecessary constraints in the future. And lithium may seem a good option today for closely knit smaller urban air systems, especially if they are designed as big sky hubs that have good power connection in certain limited number of places. But hydrogen already today looks like a more likely future-proof option. Hard to come up with numbers. Thank you, Daniel, that you were doing these projections. I think it deserves a PhD dissertation to actually go through all the value chain and see how different decisions, how different scenarios kind of lead to other efficiencies and other scenarios. But one thing we should not forget is the environmental benefits of fuel cells compared to, of course, what may be considered an ecological disaster of even recycling a lithium battery. So I do believe we should work together and towards more community acceptance of this technology, to more regulatory awareness and availability of this technology for eVTOL developers and manufacturing companies like ourselves. So thank you very much for your attention.
Thank you, Ilya. Thank you, Steve, Daniel, and Ilya, everyone, for your visionary and very enthusiastic presentations. If you have any question, please type in your question in the chat box. Meanwhile, I'd like to ask you a question. This is a question to all three of you. Korean government wants to start commercializing UAM service in 5 years to 2025. My question to you is, would you recommend hydrogen fuel cell powered eVTOL for UAM commercial service in 2025? If so, what would be the product, the eVTOL features? Or if it's not possible, then what are the roadblocks to achieve the using a hydrogen powered eVTOL by 2025? Anybody first? Steve? Oh, Danielle first, yeah.
Yeah, I can go. So of course I'm gonna say yes, recommending hydrogen. I think as a service, like we said, medical, kind of where we see the opportunity is looking at what is already being done with VTOL. Like look at your typical helicopter operations in if you have a medical emergency where you've got to get somebody in a helicopter. You know, maybe you're, you know, doing search and rescue or disaster response. These are operations that are done with helicopters already. And so what we can show is that you can do, and so instead of trying to reinvent the entire system, because we don't really see it going, you know, just from having a drone to urban air mobility where we're, you know, landing on rooftops. We think there's steps to get to that. And we see the first steps as being cargo delivery, and then next using it for, you know, like the medical, the things that we're already doing with helicopters. And we can show, hey, we can do what you're doing for cheaper and with no emissions. So I think that's just a real obvious one for us going forward. So that's where I would start if it was me.
Thank you.
Sam, I think your question is
Yes,
the one that is being asked by many people. What is the time period? And as I said in my presentation, predictions they come back to bite you. Igor Sikorsky said one time, if you're planning a program on a technology breakthrough, you probably will miss your milestones. I'm paraphrasing what he said, because we don't know when that breakthrough will come. And the point I was trying to make is that the payload for UAM, for passenger, for heavier lifting than the current drones are doing with 25 or 50 pounds, is not there for aviation quality, pure hydrogen fuel cell power today. So I think what you're hearing from this small group is that some form of hybrid battery, wing, and maybe early hydrogen uses in that hybrid propulsion and lift is the way something's going to happen sooner. Whether it's 2025 or not, I'm very skeptical. I was very optimistic. And because you know, of the time that I spent developing the hydrogen work we did at Alakai, I have to protect the intellectual property that's there. So I can't really speak, even though I'm no longer with the company. But I think there are challenges for the hydrogen fuel cell industry that they've addressed for cooling systems for major cyber companies, for small drone applications, for space application, for buses and trains, but that doesn't cross over what's needed in aviation, even for flying at low altitudes, because you need different pressure of the oxygen for going to the higher altitudes with hydrogen as well. And I think that'll just take a number of years based upon I've certified a lot of rotorcraft and fixed wing over many, many years. And it's not simple in terms of you have to have regulations that protect the safety of the public, and they have to accept that. So there's education about hydrogen. There's regulations that have to be adjusted for something that doesn't exist today. That's what we've seen in my background with doing some novel approaches like the helicopter with no tail rotor. How do you certify a helicopter with no tail rotor and give somebody a pilot rating to fly it if they're going to go fly a helicopter with a tail rotor? It's different. And so all of those are part of the regulatory environment. It doesn't matter whether it's Korea or America or China, those have to be done in the interest of the public and the safety acceptance, because the best way to kill a program is to have an accident. It will kill the concept as well. And we have so many technologies that are now maturing, and the one that is lagging is the hydrogen fuel cell, in my opinion. So that's what's going to drive that timetable, as opposed to figuring out where we're going to land. We'll figure that out. It'll take a while to figure out how many landings per hour can you make. Do you go to diverse locations? And I believe that one of the things that has not been addressed, I just didn't say it in my presentation, is if you look at the growth of the worldwide net, when they went to distributed processing from large central processors, we had a massive growth in use by other applications just showing up. The central processor became the limit, just like airports are the limit right now in the number of operations per hour. And those are the things that will really make eVTOL and urban air mobility go fast. So there'll be some small applications of hybrid propulsion or lift, maybe by 2025. Yes. Will they be pure hydrogen? I doubt it. That's my personal opinion. Again, by the kilowatts per kilogram of hydrogen. However, so that I make my point again that I was trying to make in my presentation, hydrogen will lead the large development in the long run because of the environmental friendly aspect, because of the higher energy density that we have. And one of the questions that came up from an anonymous attendee was the fear of hydrogen. It's going to explode, and the Hindenburg, like Danielle they were bringing up. But that's a matter of education, because hydrogen, in fact, is probably safer once people understand how you use it. Those could limit us if we don't do it right as an industry. So I think all of those will affect 2025. 2030 might be a better guess, Sam.
Thank you.
Can I chime in? If you were, I think if you were to make a decision about 2025 and make this decision today, I would go for hydrogen. And that would be a very difficult decision for you because there are 200 eVTOL designs out there that are not doing hydrogen, that are doing lithium. But the good news is, I think if you target hydrogen, it's only a little augmentation or little changes. You just need to be aware of what hydrogen aircraft will be needing, and that doesn't cost much to be prepared for that opportunity. If that could be my main argument, but I have a couple of more. It was a very interesting observation. I mean, we don't have moon bases, right? I mean, in the 50s, all those Isaac Asimovs and sci-fi writers thought about us having moon bases, Mars bases. We don't have that. At the same time, we tend to overestimate what can happen in the long term, but we always underestimate the amount of change that can happen in the short term or medium term. There was this notable example of a well-known company predicting how many cell phone users there will be by the end of the century in the US. They missed by a factor of 100, I think. The amount of, imagine how much investment into the infrastructure did not happen because that consultancy company was so cautious about not addressing the trying to be on the conservative side about how much change can happen. You never get fired for being conservative. You can't measure the benefit that never happened. Or the investment that never occurred. You can't lose on this investment. I think that in 5 years there will definitely be several very good hydrogen fuel cell technologies suitable for eVTOLs, but maybe not in mass manufacturing, not in certification. And if you're speaking about bottlenecks, these are the bottlenecks, not the non-availability of technology. Bright people are working on it. So in order to avoid that bottleneck, the big manufacturers, the regulators, have to become more aware of that technology real stage and support it so that development comes more or less in parallel with creating the manufacturing capability. Because there are many companies out there. The demand will be huge. This symposium only shows it. So it only stands to reason that the corporates, the manufacturers, they shouldn't wait to see, okay, show us the prototype, show us that it works. It works. It has already been proven a number of times. It can work. So preemptive manufacturing, preemptive regulatory awareness, these are the two things that will help to make this technology put to use in our industry as I believe it.
Thank you.
Just,
Thank you, everyone.
just to add one last thing
Yeah.
too, you know, if you're kind of looking at hydrogen versus lithium ion, there was a presentation from Tesla, I think about 2 weeks ago, where one of their executives said that the wait to even get access to lithium is 4 to 5 years. So where, you know, the hydrogen fuel cell technology may not be as mature as lithium ion batteries, they're about to be running into some challenges where I think it'll give hydrogen a chance to catch up. So something to consider. You can find that online as well.
Thank you. I received a couple of questions from audience. This question goes to Daniel and Ilya. I'm not sure whether you could answer this question, but let me ask you. What it says is, you know, after you guys have FAA certification of your, you know, aircraft, eVTOL, and what could be the final retail price of your vehicle? Can you answer this question? Just, you know, maybe ballpark figure or range, or, you know, it depends on many factors. Yeah.
Yeah, it depends. I'll say, you know, being that we're doing things that have never been done, it's difficult to give a realistic figure, but our goal is aggressive, and we want to be able to show lower numbers than what exists for the current operations. So comparable and lower. So you'll have to do some research on that to get an accurate number.
Okay, now, Ilya?
Well, I think the main factor, well, first of all, of course, we know a lot about the mass manufacturing of lithium batteries, but we know little about the final price for mass manufactured hydrogen fuel cell. So let me first speak about the lithium version. With that, our aim is, our goal is to start with small scale manufacturing, to start with about the price range of inexpensive helicopter, which usually falls within the range of $400 to $600, maybe $700,000. The indicative, I think the whole point of the disruption that comes in this market is that distributed electric propulsion, composites, flight control, electricity, they basically must make flying more affordable than it is on helicopters. Otherwise, how do we compete at all? I mean, if helicopters are better, which they are not, we will be better. We as the industry, we must be 10 times better than helicopters. The small scale, I mean, I'm not saying the big ones. The big ones have their own efficiencies, their own use cases. We are speaking about business aviation, 2-seater, 4-seater type of arrangement, helicopters. And then we tend to believe that when massive scaled manufacturing comes, and we are talking about automotive scale manufacturing, tens of thousands of vehicles per annum, the price should go and compare to an expensive sedan. That's basically another kind of range of the idea, because with the expensive sedan, you already know that you can run a very efficient air taxi, ground taxi operations. Most of the taxis in Europe are expensive sedans. It's kind of another price point where the industry will go. But again, aviation has never experienced tens of thousands of vehicles manufactured per annum. So we really, there are many variables, but we believe that automotive industry has century-long experience in doing complex stuff cheaply, and then they know how to do the efficiency. So aviation industry will learn from that a lot. Now, speaking about the hydrogen, those numbers were about lithium. Speaking about hydrogen modification, really hard to say. I will leave this I guess open, because it's really, I mean, you can extrapolate from what you believe the lithium battery costs and what you believe the hydrogen fuel cell solution will cost, and then the rest will not differ much, really.
Okay, thank you. I have a last question, and then I'm gonna wrap up, finish this session. This question is from the questions from the floor. This question goes to everyone. What do you suggest for collaboration to speed it up, or development and deployment of UAM service with hydrogen powered eVTOL? Maybe Ilya or Daniel, maybe both of you could even elaborate how are you open to do any collaboration in research and development, specifically with Korean companies, or are you interested in developing and producing eVTOL together? What could be the condition for collaboration? If you have a few words, and please do so. Steve, any suggestions for collaborations? The last comment.
Yeah, it would be comments, because I don't have a company that would be collaborating, but I've looked at that in a number of cases. I think Ilya said a lot of very appropriate things for collaboration. It's about mass production, and for the supplier network to be developed for the hydrogen subcomponents, for example, it needs high volume. It's not just about aviation uses, it's about automotive and the other buses, trains, et cetera. That when those are common, which is why I was saying we need standards, then it becomes simpler for the supplier to plan, I'm making this component to fit a wide range of fuel cells. And that will drive the price down by them getting volume. And then the volume that will come in the industry is where, using Hyundai as an example, if Hyundai tried to just build automobiles for Korea, their price would be much higher than when they become a world producer of automotive over the last 3 decades, if I have my dates right. And they have become, a part of a much bigger industry than they would have just localized. And so any of us that look at collaboration in a world sense, that's the only way this is going to go faster, because we need to have some form of mass numbers to drive it down. But I would add one thing for both Danielle and Ilya. Complexity drives cost, period. Empty weight drives cost, period. So the heavier it is and the more moving parts you have, the more expensive it's going to be. So as an industry, the collaboration also needs to be on finding that common denominator of simple and getting the weight down so that we can put it in a payload. So, because the more people, the more value proposition you have. I don't know if that answered the question very well, but I'll pass to.
Yeah. Daniel, are you open to any collaboration with Korean companies?
Yeah, absolutely. Something that we're really interested in that we'd be open to looking at is kind of this. I encourage you to check out a company called Nexa Advisors, and they did this like city by city study, and they basically advise infrastructure investors. And I agree with Steve, we'll figure out where they'll land, but also sort of their approach and their idea is going like city to city. So you could maybe look at Seoul as, the first city that you want to, because I think if you try to do it, from the whole country standpoint, it might be a little bit daunting. But if you just looked at one city and got all of the players involved, which you already seem to have a really good start on with your Team Korea, the UAM Team Korea. Something that we're doing in LA is putting together a consortium where we're getting everybody involved and then sort of making a roadmap for how this will be implemented into the city. And we'd be interested in doing something like that. I don't think that it's, you know, technology that's going to drive the implementation, although the certification certainly will. That's going to be, you know, that's one of the big, you know, milestones to achieve. But the technology is pretty close to being there, especially on the aircraft side of things. It's just, you know, the drivetrains are where we're kind of struggling. But you know, kind of leave that part to the engineers, and then, but getting all of the stakeholders, like all of the people that are going to be utilizing this technology, all of the decision makers, getting everybody involved, from, you know, all of your fire, police, you know, mayors, whatever, anybody that's going to be part of it, to form this group and come up with a roadmap of what do people want and what do people need. Because what you don't want to do is create an ecosystem that you later find out that nobody wants. So kind of figuring out what will benefit people and what do they need. And so to kind of create that roadmap around, you know, the city's needs and demands. So that's my 2 cents.
Thank you. Let's move on to Lilia.
Yeah, well, there are 3 things, 3 big heaps on my desk to which I have to attend. Now, one is called supply chain. Again, this is aviation trying to become automotive scale. Supply chain management has to be different, and it has to, you know, also include companies who are capable to manufacture the components we need en masse. Secondly, it is manufacturing. Even our design decisions are at times driven by analysis of mass manufacturability, of manufacturing practices that may be used by a presumably automotive player or of the like in the future to manufacture this type of vehicles. So that interaction early on is something that educates us and creates first mover advantage to any manufacturer that talks to us. Well, after all, almost if you look at all these eVTOLs, after all, it's composite motors, wires, props, and avionics. So maybe the manufacturing practices are to be aware more of those manufacturing practices, something that the manufacturers are interested in. And the third one is clients, of course. We are speaking to clients worldwide to understand better preferences and requirements, and the operational perimeter in which the vehicle will be used and the different use cases. And we have learned of quite peculiar, quite interesting user stories that different people want to put these vehicles to use. I mean, in detail, not just speak like just tourism or just medical or just, I mean, what is medical? Do you really have a moving hospital, for example? Daniel, have you? I'm pretty sure you have thought about this much more than I have. I'm actually quite curious to hear your thoughts if the moderator allows. But even medical application, is that flying hospital where you treat patient on site, or is it a fast kind of delivery of patient to the hospital where the speed matters and then the hospital treats the patient at the hospital? That sort of choice leads to a different vehicle. So it's clients, it's understanding who and how would want to use those vehicles, which would educate us more to create a better vehicle for clients. So these are the 3 connections, 3 types of connections that we are very eager to establish with as many players in this world. Because everywhere conditions are different, circumstances are different, and intents are different. So it's interesting to be able to learn of that. Thank you.
Thank you.
Sam, could I make one other comment? In the keynote address there was a discussion about certification in Korea. I would like to offer, I think, an answer to your question of collaboration. I would be glad to collaborate with the keynote speaker and the ministry about the certification, where we know in Korea it is still a early stage of doing this type of development. Would be glad to help with that and collaborate in a non-company specific manner, but with the knowledge of the FAA and EASA and certification programs. I think that will help accelerate because again, the last thing you want to do is certify and it not be safe. To me,
Yes.
the time goes.
Thank you. I think we have, this is very exciting and we have a lot of energy and still I see some questions. However, our time is short. We have, I thought it's going to be long hours, 4 hours, but we have only 1 hour remaining. So I have to move on. Okay. Let's go back to the session 1. I'd like to introduce the next speaker, Val Mikotakov, CEO of ZeroAvia. Are you ready?
I'm ready.
Yeah, please go ahead.
Sam.
We have very short.
All right, so I will present, right, from my screen, yeah? Mm-hmm. Okay. All right, let's do this. Okay, can you see my screen?
Yeah, sure. Go ahead, please.
All right, great. So Val Miftakov, CEO and founder, ZeroAvia. We build hydrogen electric powertrain for aviation. And we think, of course, that hydrogen electric is the right answer for aviation of all kinds. And I know I'm preaching to the choir, so we'll go through some of these things relatively quickly and focus on the things that perhaps were not covered yet in this presentation or this event. So we all started, actually my story is before this company, I had a company in the electric vehicle space on the grounds, battery vehicles and charging infrastructure. We built the largest network of smart chargers in the United States, sold the company to a large utility in 2017. And then when it became the time to think about what's next, aviation was a natural thing for me because I'm a pilot myself. And also that was around the time when things like this started appearing. And many of you guys have seen Greta Thunberg talking about the climate change and talking about the impact on the environment and talking about the how much damage flying has on our ecosystem. And it's not just about CO2, it's about the soot particles, it's about nitrogen oxides and various other problematic effects that aviation, fossil fuel aviation has. So if you look at some numbers, this is of course a huge market. $1.5 trillion total, about $1 trillion in operations, about 100 billion in engines, 200 billion in aircraft, and 200 billion in fuel. And this entire market is getting more and more hammered with sustainability issues and sustainability pressure. So today, about 5 to 10% of total human climate impact. The emissions are actually CO2 emissions are about 2.5, 3% maybe, but all these other forcing mechanisms that I mentioned actually provide a multiple on top of that in terms of climate impact. So already 5 to 10% today. If you look at the business as usual trajectory, the efficiency improvements of aircraft and engines just do not catch up to the growth rate of aviation. Now we're in pandemic and everything is went down, but we're going to come out of it, and 2 years from now, aviation will be back in the growth spurt, and this is what we're going to see. In the business as usual scenario, we're going to see 25, 50% of total human climate impact from aviation, because everything else is getting cleaner, right? You have ground transport. This is my previous company, previous world, getting cleaner and cleaner with electric cars, trucks, and so forth. The power industry is already getting much cleaner, and industrial use buildings and all that. So aviation is really becoming this outlier, and there is no real solution today. Like if you go to the large airlines, large operators, all they talk about right now is offsets and carbon offsets, carbon credits, trading, and all those things, which are all fake sustainability, in our opinion. So we really need to solve this through technology. So you know, and as you know, everybody wants to fly. So as soon as the quality of life increases to a certain level, people want to get on the plane, want to go on vacation, want to go to that business meeting. And a lot of new airports are built in the developing world, in China. Huge number of new airports. Everybody wants to fly. And then, as presented in the previous panel, you know, there's the whole 3D sort of personal transportation revolution is upon us and will be coming in. And of course, here is a Fifth Element. Nice movie, those who haven't seen, but very visionary. And that's what we're going to have. And that's a lot of additional aircraft in the air. So we need to solve it. So how do we solve it? There are basically 6 different ways to think about it. And we at Zero Avio, as we started about 3 years ago, we did it, this thinking from the first principles perspective. I'm a physicist myself, PhD in physics. My management team is similarly suited as well. And we looked at the fundamental physics of various solutions. So of course you have batteries. This is the first one here. Then you have turbine hybrids. Then you have biofuels. Then you have synthetic fuels. Then you have hydrogen turbines, which is interesting. We'll talk a little bit about it. And then hydrogen electric, hydrogen fuel cell, and electric motors. And we looked at all of these from fundamental perspective, energy density, efficiency, you know, theoretical limits, all of that. And this is what we found. On battery electric, we just have fundamental blockers. And again, I'm not going to spend a lot of time. We already talked about it, energy density, all of that. In addition, cycling material, sourcing issues and whatnot. Turbine electric, yeah, could work, but it doesn't really make any sense. You're not extracting any significant fundamental improvements in fuel and efficiency. Biofuels can't really scale. If you look at plants as a way to convert sunlight into fuel, that's just dumb. It's not getting any kind of efficiency. It's 500 times less efficient than solar electrolysis on the same piece of land. And you're not even talking about the water issues, environmental impact of agriculture and all those things. So really what remains on the bottom is our 3 hydrogen-derived solutions. Synthetic fuels take hydrogen, so make hydrogen through electrolysis, zero emission, because no other way of making hydrogen, zero emission hydrogen will really scale. So you make hydrogen in each of those cases. And in the first case, you then have another chemical plants to convert that hydrogen into synthetic fuel. The benefit is you can use that synthetic fuel in the existing engines and call it a day, at least on the emissions basis, on the CO2 emissions basis. The problem is all the other issues that you have with burning fossil fuel. Now, in this case, not fossil anymore, but synthetic. All other issues remain. So that multiple on the CO2 from a climate perspective still there. And then this fuel is crazily expensive, right? So hydrogen itself has a little bit of a cost problem and we need to work on it. But then you add the whole new cost and efficiency kit of the chemical process to capture the air from the atmosphere and then bind it to hydrogen to create fuel, right? So cost is a huge barrier. And then you have all the disadvantages of burning fuel. Hydrogen turbine, better. So at least you don't have the penalty of carbon capture and all those things. You can use hydrogen directly. The problem is that Turbines would still have some of the nitrogen oxide emissions. They're not as efficient as hydrogen electric powertrain. The maintenance is higher. And we think the best solution is really hydrogen electric from the first principles. Like, you look at it and really you combine the superior energy density of hydrogen, 3 times better than jet fuel per kilogram basis, and superior efficiency of the electric powertrain. And you combine the two, you get the best solution. So that's what we think is going to happen over time. What we need to work on is here on the bottom right, secondary issues. We need to work on the power density of the fuel cell systems and the volume and weight of the fuel storage. And that's what some of the big things that we at ZeroAvia are working on. So with that, our vision is renewably powered hydrogen electric aviation, make fuel, make hydrogen on site at the airport from local renewable supply, and fuel the planes right there. We can deliver not only zero emission, but also lower costs and match the range of the fossil fuel aircrafts through that. We also think this product is going to be better than jet engines, just similar to how electric cars are better products compared to gasoline cars, even internal combustion cars. Hydrogen electric aircraft will be better product compared to fossil fuel aircraft. You have lower and stable fuel costs, and the industry today spends a lot of time and money on hedging against the fluctuations of the oil prices and whatnot. None of that is here. Electricity is much more stable commodity. Even if you don't source it from your dedicated renewable arrays, if you have dedicated renewable source, then a complete stability, lower maintenance costs, again, electric powertrain versus internal combustion, high pressure, high temperature, lower noise levels from electric powertrain, and ability to build more efficient airframes. Once you have electric propulsion, you can think about distributed propulsion, you can think about various solutions on the thermal management and how you deal with drag of that. So more design space opens up. So it was great to see over the last 12 months, especially that hydrogen momentum is accelerating. We were participants in this study that the European Union put out together with McKinsey earlier this year in May, that basically said future of aviation is in hydrogen, and we were profiled in that study as well. And then you saw what the French government did, and Airbus announced just 2 weeks ago, all in on hydrogen as the future of aviation. And I sat on the panel at KAEA with Guillaume Faury, the CEO of Airbus, and he basically made my pitch for hydrogen. It was great. So we see the majors of the industry are coming in as well. So this is what we are working on. We're a power plant company. We build engines, right? And we also have a big play in infrastructure. I'll talk about it a little bit later. But for now, focusing on powertrains. First commercial offering, 600 kilowatt powertrain goes into aircraft like this, 10 to 20 seats, 500-mile range. And then we go from there into larger and larger aircraft, longer and longer distances. By the end of this decade, we will have 100-seat, 1,000-mile aircraft in the air. So we're not just talking about it, we're actually doing it. On the bottom, these are actual things that we're doing. We built our first prototype last year in 2019. We flew it here in the United States. Then we won a major grant in the UK, built up operations there, built our second prototype there, started flying, and 2 weeks ago on September 24th, we had the first flight of the world's largest hydrogen electric aircraft, 6-seat Piper, pressurized airframe, 2-ton aircraft. And later this year, in a few weeks, I guess, we'll be demonstrating up to 300-mile flights on that platform. And then later this year as well, we're switching over to the 19-seater aircraft. What you see basically there on the picture under the first commercial offering, 19-seat aircraft, starting testing of 600 kilowatt system, flight test next year. And this is some of the news you probably a lot of you have seen in the news, but this was pretty historic. We had the Minister of Aviation for the UK. We had Prime Minister mention that in his speech on sustainability. It was a great day for aviation overall. We're also in the UK. We're part of the a new initiative that Prime Minister set up, and this is our kickoff meeting here earlier this year, in September probably or August, where the initiative is about getting a 100-seat jet in the air by 2030. If you remember from the roadmap, this is exactly what we're planning to do. We are one of the 5 aerospace companies on this council, alongside with Rolls-Royce, Airbus, and similarly sized majors. So we're doing something right. As I mentioned, in addition to the powertrain, we're also building the hydrogen airport refueling ecosystem. So this is all real hardware that works today at our R&D facility in the UK, Cranfield Airport, about 50 miles north of London. A renewable array that was already there, so we're just feeding off of it. We built the electrolysis system, the on-site storage, transfer pumps, and the fuel truck that you see here on the picture on the top right, that is running around the airport, similar to what you see at airports with fossil fuel airplanes. They're fueled by fuel trucks showing up and putting fuel in your plane. Same thing here. We already have it. It works. We partnered with Toyota for some ground vehicle support, as they gave us an initial first Mirai, and we're getting a second one pretty soon to do some demonstrations of how our fueling infrastructure can be used for various types of mobility, not just in the air. And in fact, we think that over time, hydrogen infrastructure, production and refueling infrastructure that is built on the airports will be the starting point or some of the nucleus for the infrastructure for other types of transport. Airports are natural transportation hubs. People show up there, goods show up there, trains come in, trucks come in, cars. It's a great place to have production of fuel and distribution of fuel, and we're already doing it. On the economics of hydrogen, so we actually think that you can get to $3 to $4 within the next 4 years on green hydrogen at the right volume. The volume is key. This assumes you have localized production of electricity, let's say from a large renewable array, and these already exist in places like California, or Arizona, or Mexico, with good solar irradiation, selling energy at very low price already today. So if you have something like this and you build a 100 megawatt electrolysis facility, you are going to see $3 to $4 per kilo at the pump, at the airports 3-4 years out, right? And by the way, that will mean that we are beating jet fuel pricing, at least pre-pandemic levels jet fuel pricing. We've also done a lot of analysis and modeling and real quotations for the infrastructure with various people, large electrolysis companies, and we can show that we can not only get the economics at scale, but also scale profitably to that, especially with small operators that pay a lot higher jet fuel prices than United or Korean Air and other large carriers. Overall, the fuel market is, of course, very attractive. As I said, $200 billion today in fuel. We think we can, over time, move the entire aviation to hydrogen, and that is a huge market, 50 to 100 megatons of hydrogen a year. This, by the way, looks large, but 100 megatons is what the industry makes and uses today. Right? The worldwide industry, fertilizer, oil refineries, industrial use cases consume, I think last year, over 80 million tons of hydrogen being produced, stored, and used in those processes. So the industry knows how to make it, how to store it, how to use it, how to safely handle it. So this, of course, would mean doubling it by 2050, but it's not, starting from zero. But it is a huge new market. So we have a lot of the large fuel companies, large industrial gas companies, very interested in this potential. Of course, since we have been so active in the market and actually have done a lot of tangible things, we have hardware in the air. We're the only company that has hydrogen fuel cell aircraft of this size up in the air, and we want to continue to continue that leadership. We got a huge footprint out there, captured attention, not only of the media on the left here, but also on the right with the operators. We have a number of signed LOIs. We have discussions with all the majors, well, not all, but many majors, new vehicle manufacturers, and the governments. I already mentioned the UK, and there's some other governments that are looking to support us. So I'll stop here, see what questions you have. So this is the message I wanna leave you with is, it's not only the future, it's reality, and it's becoming real, and we're making it happen.
Thank you. Thanks, Val. This is a very exciting news. I have a first question, and then afterward, if anybody has a question, please write down your question in the chat box. It seems you had a world first hydrogen fuel powered flight successfully done September this year. I think that you should have got a lot of support or partnership with your industry in England. My question is, what was the role and support from you received from UK government? Was it helpful?
Hugely helpful. So the UK government is, and I would recommend any R&D companies to consider talking to the UK government. And if you want some pointers, contact me, and I'm happy to make introductions. We were super impressed with what they were doing, and they're still, I think, the only country that has an initiative like Jet Zero, for example, and that perhaps is some of the best practices for Korea, perhaps as well, right? Because I think Korea has a lot of fundamentals going for it. It's a known hydrogen economy leader, right? With Hyundai and some others pushing the boundaries there. It has some very good fundamentals, and maybe they could borrow some of the ideas and create new ideas for how they can support innovative R&D in this area.
Mm-hmm. Are you interested in collaborating with others in overseas outside UK?
Absolutely. And in fact, in my previous life, I was actually, when I was at McKinsey & Company, management consulting, for about six and a half years, I spent almost 2 years in Korea. Some of the large Korean conglomerates were my main clients. Spent a lot of time in Seoul and Suwon and a few other places, and I know how big the sustainability angle is in Korea, and the world's busiest routes, short distance route, is Seoul to Jeju Island, almost 15 million passengers a year take it. It's just 450 kilometers. It is ideal for this type of solution, and I would love to make it happen.
I see. Are you interested in, or are you planning to sell your aircraft to overseas as well?
Yeah, absolutely. And again, you know, we are a power plants and infrastructure company. So we work with existing aircraft manufacturers, existing operators. In a lot of cases, we would even, you know, change over the engines in the existing fleet, like the way we engineer our systems. And that's how we did the aircraft that we're flying today. It is a commercially available aircraft. And if you bring us that aircraft, we can, or 10 of them, we can make them hydrogen electric, you know, tomorrow, right? So that's the idea. There are a lot of airframes out there. There are good airframes designs. There are people who know how to build aircraft. And we want to work with all of them as an engine company, and then with operators as the infrastructure company to make sure that everybody has secure fuel supply.
Okay. There is a question from Flora. Are you interested in the intercity regional air services in Korea? Are you interested in providing services?
Well, we wouldn't be an operator, but we would love to work with existing or new operators that would like to use this technology and differentiate themselves as you know, sustainable operators and lower cost operators. In fact, as I mentioned, right, the maintenance costs and the fuel costs will be lower. So yeah, we have out of, I think, 12 or 13 LOIs we have with the airlines today. 4 or 5 of them are with the sub-regional operators. Some of them have new business models that they're looking to enable with our power plants. So yes, we would love to talk.
You know, when will be, you know, at this time, the dominant technology in short haul and long haul in air and airline industry is, you know, the gas. Do you think, you know, hydrogen powered aviation will become break even or comparable to existing the you know, gas powered aviation? When will be?
Yeah, I think the answer is depending on the size of aircraft, right, and the size of the operator. So we are starting, as I mentioned, in the 10, 20 seat aircraft that is generally operated by smaller operators. They have higher fuel costs. The aircraft is less efficient. Small turbines are very inefficient relative to the hydrogen fuel cell based electric powertrain. So from the very beginning, and very beginning for us is about 3 years out when we have the certified solution. From the very beginning, we'll be able to break even and maybe even do better economically on the operating basis compared to the fossil fuel.
Excellent. I'd like to, because, you know, time is short, I'd like to wrap up this session. Do you have any final remark to the audience in Korea?
I think we should work on getting something going in Korea, and like I said, you know, some of the best short routes are there, and we would love to see zero emission aircraft flying there before too long. I think we can do it.
Excellent.
Okay.
Congratulations on your achievement, and I look forward to, you know, seeing your collaboration with Korean government as well as industry. Okay, thank you. Next, I'd like to, I think we are on time now, finally. Next, we're gonna have a panel session 3. This time, Chanya Park, Mr. Park, team leader, digital integration team leader of Jeju province in Korea. He will present about their experience with emergency hydrogen drone delivery service in Jeju Island. Mr. Park, are you ready?
Hi.
네.
안녕하세요. 저는 대한민국 제주특별자치도에 근무하는 스마트시티 드론 팀장 박찬혁입니다. 오늘 심포지엄에 초대받게 되어 감사드리며 우리 제주도에서 추진하고 있는 드론 행정정책을 소개할 수 있게 되어 매우 영광입니다. 오늘 행사를 준비해 주신 관계자분들과 조세킴 회장님께 다시 한번 감사드립니다. 먼저 잠시 화면 공유 좀 하겠습니다. 그럼 지금부터 제주특별자치도 잠시만요. 그럼 지금부터 제주특별자치도 글로벌 드론 특화도시 조성 방안을 서비스 사례 중심으로 소개해 드리겠습니다. 준비한 콘텐츠는 화면과 같습니다. 그럼 먼저 드론 실증도시 사업 계획부터 설명을 드리겠습니다. 최근 드론은 4차 산업혁명 시대에서 미래 신산업 핵심 기술로 떠오르고 있습니다. 특히 제주도의 넓은 해안과 한라산, 도심지, 농경지 등 다양한 제주 환경을 대상으로 각종 도시 문제를 효율적으로 해결하기 위한 핵심 기술은 드론뿐이라고 판단하고 있습니다. 그러나 드론 이런 서비스 상용화는 드론 성능과 규제 어려움으로 겪고 있습니다. 이에 따라서 국토교통부와 저희 제주특별자치도는 2019년부터 드론 규제 개혁과 상용화 서비스를 추진하기 위해서 드론 규제 실증도시 사업을 추진해 왔고, 제주도에서는 올해까지 2년 연속 계속 실증하고 있습니다. 현재 제주도는 쓰레기 때문에 아름다운 제주 해양이 심각하게 오염되고 있고, 관광 산업이 발전하다 보니까 음주 문화도 발달되어 강력 범죄가 심각하게 발생되고 있습니다. 또한 농업 비중도 매우 높은데 월동작물 생산량 예측 실패로 농민들이 어려움을 겪고 있고, 국립공원 한라산에는 소나무 재선충이 발생되어 청정 환경을 훼손하고 있습니다. 이러한 도시 문제를 해결하기 위해서 저희는 3가지 실증을 추진하였습니다. 먼저 첫 번째로 태양광 드론을 이용해서 해양 환경 모니터링 서비스를 추진하였고, 두 번째로는 강력 범죄 예방과 CCTV 사각지대 안전 대응을 위해서 안심 서비스를 수행하였습니다. 세 번째로는 월동작물과 소나무 재선충 모니터링 서비스를 추진하였습니다. 드론 규제 샌드박스 실증도시 사업의 주요 목적은 다음과 같습니다. 먼저 첫 번째로 지방자치단체의 이런 지역 문제를 해결하기 위해서 드론 서비스 모델을 발굴하는 것이고, 두 번째로는 이런 기후와 임무에 맞게 드론 기체의 성능을 향상시키는 것입니다. 그리고 세 번째로는 이러한 상용화 서비스를 위해서 비가시권 비행이라든지 고고도 비행, 야간 비행과 같은 이런 주요 규제에 대해서 안전성을 검증하는 것입니다. 19년도에 추진한 실증 결과는 저희가 모두 이제 성공적으로 추진했습니다. 그렇지만 이런 상용화 서비스를 추진하기에는 일부 한계도 있었기 때문에 저희가 20년도에 추진했던 사업에서는 좀 더 안정화를 위한 고도화 사업을 추진하게 되었고, 또한 안전 예방을 위한 신규 사업 서비스 모델도 확대하기 시작하였습니다. 그러면 이제 우리 제주도에서 추진했던 이런 실증 내용들을 좀 더 자세히 사례별로 보여드리도록 하겠습니다. 실증은 크게 화면과 같이 3가지 과제로 추진하였습니다. 먼저 첫 번째, 스마트 드론과 스테이션을 이용해서 도심 지역에 대한 안심 서비스를 추진하였고, 두 번째, 태양광 드론을 이용해서 장시간 비행하며 해양 모니터링 서비스를 추진하였습니다. 세 번째로는 두산 수소전지를 이용해서 안전행정 모니터링 서비스를 추진하였습니다. 그럼 첫 번째 스마트 도시 안심 서비스부터 자세히 설명드리겠습니다. 지금까지 안심 서비스는 주로 도시 외곽 지역에서 진행해 왔는데, 우리 제주도에서는 고도심 지역을 대상으로 우리나라 최초로 실증을 시도하고 있습니다. 호텔과 오피스텔이 가장 밀집된 고층 빌딩 지역으로 관광객이 가장 많이 방문하고도 있고, 강력범죄 발생 우려도 높은 제주 연동 지역을 대상으로 서비스를 진행하고 있습니다. 실증 시나리오는 보시는 그림과 같이 관광객이나 자치경찰단이 안심 서비스를 웹을 이용해서 호출을 하게 되면 통합관제 시스템을 통해서 명령이 전달되고 스마트 스테이션에서 드론이 자율비행하여 임무를 수행하는 체계입니다. 보시는 영상은 스마트 드론과 스마트 스테이션에서 드론이 출동하고 다시 복귀해서 자동 충전하는 영상입니다. 이번 영상은 웹 호출자의 스마트폰 GPS 위치로 자율비행해서 임무를 수행하는 영상입니다. 그리고 이번 영상은 야간 비행에 적합하도록 드론을 개조한 영상 자료인데, LED와 열화상 센서들을 탑재해서 임무를 수행하고 있습니다. 두 번째 실증 내용은 태양광 드론 기반의 해안도시 환경 모니터링 내용입니다. 제주도에서는 태양광 드론을 이용해서 올해 32시간 연속 비행하는 데 성공하였고, 최근에는 제주 공항 지역을 제외하고 제주 연안 전체 258km를 한 번에 비행하는 것을 성공하였습니다. 그럼 이제 제주 MBC 방송국에서 태양광 드론으로 제주 해안에 모니터링하는 뉴스 영상을 보여드리도록 하겠습니다.
소형 항공기처럼 생긴 고정익 드론입니다. 제주 해안을 날아다니며 괭생이 모자반이나 쓰레기가 밀려오는지, 안전사고가 발생했는지 여부를 모니터링합니다. 보통 드론의 비행시간은 30분에 불과하지만 이 드론의 몸체엔 태양광 전지판이 붙어 있어서 7시간 이상 비행이 가능한 게 가장 큰 장점입니다.
네, 이번 영상은 태양광 드론으로 LTE 통신망을 이용해서 실시간으로 영상을 전송해주는 화면입니다. 모두 실시간으로 자동 매핑과 함께 AI 기반에서 해양 쓰레기를 탐지하고 있습니다. 파란색 부분과 같이 작은 페트병 하나까지 자동 탐지하는 데 성공하였습니다. 세 번째로는 두산 수소 드론을 이용한 사례입니다. 일반적으로 멀티콥터의 경우 비행시간이 30분 이내이기 때문에 상용화에 어려움을 겪고 있습니다. 그렇지만 수소 드론은 2시간 비행이 가능하기 때문에 장거리 배송이 가능한 장점을 가지고 있습니다.
한라산 등반에 나섰던 60대 관광객이 목숨을 잃는 사고가 발생했습니다. 겨울철이 되면서 산악사고가 잇따르고 있어 겨울 산행에 각별한 주의가 필요합니다.
네, 보신 영상은 그 한라산 등산객이 그 심장마비 사고가 발생되어 수도전으로 응급 구호물 에이드를 긴급 배송해 주는 그런 시나리오의 영상입니다. 그럼 이제 우리 제주도가 추진했던 좀 흥미로웠던 이벤트 성과들을 보여드리도록 하겠습니다. 우리 제주도는 그 코로나19 감염이 그 심각하고 마스크 구매가 어려웠던 지난 4월에 수소 드론을 이용해서 공적 마스크를 외딴섬 지역으로 배송하는 서비스를 추진하였습니다. 이곳 외딴섬 그 가파도와 마라도, 비양도에서는 공적 마스크를 판매하는 곳이 없어서 배를 타고 와서 오브제에 맞추어 직접 마스크를 구매해야 하는 큰 불편을 겪고 있었습니다. 제주도와 두산 모빌리티 이노베이션과 함께 민간 협업으로 추진한 서비스인데요. 국토교통부에서는 그 장거리 비과시권 특별 비행 승인을 적극적으로 협조해 주셨습니다. 특히 본 행사에서는 그 제주특별자치도 원희룡 도지사님께서도 직접 참석해서 격려해 주셨습니다.
약국과 우체국이 없는 섬 지역 주민들이 드론이 배달하는 공적 마스크를 받았습니다. 제주도는 오늘 부속섬인 가파도와 마라도, 비양도를 비롯한 3개 섬 주민 490명에게 공적 마스크 1,200장을 수소 드론에 매달아서 전했습니다. 이런 방식으로 전달하는 공적 마스크는 모두 15,000장입니다.
또한 우리 제주도는 그 GS 칼텍스 주유소에서 산간 지역에 있는 초등학교와 펜션에 드론으로 간식을 제공하는 서비스도 추진하였습니다. 초등학교 학생들은 그 드론으로 간식을 배달해 주는 것에 환호했고, 코로나19로 그 스몰 웨딩을 위해 방문한 펜션의 신혼부부에게는 저희 제주도 원희룡 도지사님께서 따뜻한 손편지와 함께 도시락을 배달해 주었습니다.
배송 시연 행사를 개최했습니다. 정지훈 기자입니다.
주문받은 물건들을 차례로 실은 드론이 경쾌한 소리를 내며 하늘로 오릅니다. 배송지로 향하는 비행 영상은 실시간으로 전송됩니다. 신혼부부를 위한 도시락과 편지를 실은 첫 번째 드론은 1km 떨어진 제주의 한 펜션에 무사히 도착했습니다. 부부는 마치 하늘에서 선물을 받은 듯한 기분입니다.
감사합니다. 감사합니다. 잘 먹겠습니다. 감사합니다.
간식을 실은 두 번째 드론도 무사히 목적지에 도착했습니다. 하늘을 날아 배달된 간식을 받은 어린이들은 신기하기만 합니다.
상륙했을 때 뭔가 멋있었고 마음이 좀 많이 떨렸어요.
이제 미래 발전해서 드론으로 배달도 하는구나 이 생각했어요.
미래 기술로 불렸던 드론 배송이 제주에서 시연 행사를 가졌습니다. 드론 배송은 앱을 통해 물건을 구매하면 기존 편의점이나 주유소에서 주문한 물품을 드론으로 전달하는 서비스입니다. 산업통상자원부와 제주도, 민간기업이 힘을 모았습니다.
현재 중산간 지역이나
현재 제주도는 그 전기차 육성 산업을 추진하고 있기 때문에 이런 기존 주유소는 향후 70% 이상 폐업이 전망되고 있습니다. 따라서 기존의 이런 주유소는 그 새로운 비즈니스 모델 전환이 필요했고, 전기차 충전소 역할과 함께 퍼스널 모빌리티 거점 센터와 드론 배송 스테이션의 거점 역할로 전환하는 이런 사업을 실증하고 있습니다. 그럼 이제 마지막으로 그 향후에 추진하게 되는 제주 드론 규제 특화 도시와 UAM 실증 계획에 대해서 설명을 드리고 마치겠습니다. 우리나라는 그 19년도에 드론법이 제정되었고 올해부터 전면적으로 시행하게 되었습니다. 이에 따라서 국토교통부에서는 그 특화 도시를 공모하였고 제주도 역시 신청서를 제출하였으며 최종 11월에 확정될 예정입니다. 선정이 확정되면 우리 제주도는 그 21년부터 3년간 11개의 서비스 모델을 대상으로 제주 전 지역에 대해서 총 사업비 170억 규모로 특화도시를 운영해 나갈 계획입니다. 특화도시 운영을 통해서 그 세계 드론의 섬 제주로 글로벌 드론 메카 도시로 비상할 계획입니다. 또한 차세대 드론 모빌리티 서비스를 위해서 드론 택시 에어 투어 서비스 실증을 추진할 계획입니다. 현재 제주도에서는 그 아주 구체적으로 드론 택시 비행 시행 계획을 가지고는 있지만 좀 공식화하기 어려운 부분이 있어서 자세한 설명은 생략하도록 하겠습니다. 향후 UAM 이런 상용화 서비스를 마련할 수 있도록 저희 중앙정부와 함께 지속적으로 협력해 나갈 계획입니다. 그럼 이것으로서 저희 제주도에서 추진하고 있는 이런 드론 행정 서비스의 정책 소개를 마치도록 하겠습니다. 앞으로 제주도가 추진하는 이러한 정책이 성공적으로 추진될 수 있도록 지속적인 관심과 성원을 부탁드리겠습니다.
감사합니다. Thank you. I'd like to tell you my apologies. Translator was prepared, but at the last moment, we are told that a translator's son is sick, so translator cannot, join 찬혁 Park's presentation. 그래서 맞습니까? 제가 들은 게?
예, 맞습니다.
Anyway, thank you. Thanks for your presentation. If I wrap up, shortly, the Chanyeok presented what Jeju Island is doing lately. One of the things they are doing, we have to pay attention to is Jeju Island is going to invest more on drone delivery between 2021 and 2024. And also they plan to have a drone tour, commercial. I mean, this is more of an experimental, drone tour as a trial in a few years. And the Jeju Island hasn't, he didn't disclose fully about how they will do it, but as the plan becomes specific, and they're gonna disclose their plan. So please keep an eye on what Jeju Island is doing. Next, we're gonna show you hydrogen drone flight demonstration by Doosan Mobility Innovation Inc. Is it ready?
Many drones are currently used in various industries, and the use of drones will continue to be expanded in environments that are difficult for humans to perform. At Doosan Mobility Innovation, we provide 2 hours of flight time and the exponential opportunity that additional flight time brings to industrial drone users.
We are out at the DMI launch event for the DP30 and the DS30 hydrogen fuel cell powered drone. We've been out here for a few days. Essentially, we've got a drone here that is a SUAS, so under 55-pound drone that can fly for about 2 hours on compressed hydrogen gas, totally clean energy. We're building out an entire network to be able to refuel hydrogen and swap out tanks, so it's just a seamless, easy experience.
Islands because we are multiple islands. We're collecting samples from the other islands, but we're having to send them back. Right now we're sending them on a seaplane. Following the storms, the airports are closed, there's no flights. We are doing it by boat. People just stop going to the doctor for some things, knowing they're not going to get a result back.
We're going to launch from the island of St. Croix here, go all the way to St. Thomas, which is about 40 miles away, and we need to be able to keep the drone in line of sight, so we're just going to follow it with a boat that we've chartered.
I think the drone that we're actually using for this test is probably the most exciting part about all of this. It's the Doosan DS30 aircraft with the DP30 power pack on it. It's actually powered by hydrogen fuel cell technology, and so we're talking about 2-hour flight times instead of the typical 25 to 35-minute flight times.
Landed about 7 minutes ago.
We want to show that drones can be used to help people. They can be used to supply medicines, to be used for business, commerce, used for disaster. In terms of disasters and flooding, how do you mitigate such issues?
Doosan Mobility Innovation is specialized for hydrogen fuel cell technology, which can enable long endurance flight with the drones. With hydrogen fuel cell technology, we can fly longer hours up to more than 2 hours with multi-copter drones. I believe Africa will need long endurance, not just for delivery, but also for other various applications. Some people misunderstand that this is future technology, but this is actually in place and this is available, so you can use this technology for the application that you are pursuing now.
이번에 코로나 때문에 되게 많은 이슈들이 발생을 하는데 이 공적 마스크도 그 중에 하나로 지금 그 제주도 인근에 있는 도서 지역인 마라도나 비양도, 가파드 같은 곳에는 약국이 없다고 해요. 저희가 이제 수소 드론을 제조해서 판매하는 회사다 보니까 이왕이면은 그 마스크 중에 일부를 이 수소 드론으로 배송을 한번 직접 해보자 생각을 하게 돼서 이 프로젝트를 기획을 하게 되었습니다.
저희가 근본 프로젝트를 성공할 수 있었던 주된 요인으로는 여러 가지 이유가 있겠지만 첫 번째는 저희 핵심 기술인 연료전지 파워팩입니다. 두 번째는 저희 연료전지 파워팩에 최적화된 드론입니다. 2시간 이상 비행에 있어서 내구성과 장거리 비행에 유용하게끔 세팅이 되어 있습니다. 그리고 마지막으로는 LTE 통신입니다. 저희가 장거리 비행이 가능한 만큼 여러 가지 통신 시스템을 구현하고 있습니다. 그 중에 하나로 LTE 시스템을 구현하였고 본 프로젝트에 적용하여 가능성을 확인하였습니다.
저희 제주도는 향후에 두산과 협업을 통해서 수소 드론을 적극적으로 공공 서비스에 활용하고자 합니다. 이번에 수소 드론을 활용해서 응급 상황 발생 시에 드론을 통해 AED 심재송 발동기를 즉시 제공함으로써 인명 피해를 막을 수 있는 사업을 올해 안에 추진하도록 하고, 중장기적으로는 수소 드론이 제주도의 공공 서비스 영역에서 응급 상황이나 안전 여러 가지 카테고리에서 활용할 수 있도록 더욱 노력하도록 하겠습니다.
Thank you, everyone. I appreciate all panel participants. This is my pleasure to moderate this exciting panel discussions. Through this panel discussion, I learned a lot, and I confirmed that my belief that hydrogen fuel cell technology and energy will be the right technology for urban air mobility services. So we look forward to the development of further development of hydrogen technology and collaboration across all over the world. I'd like to turn to Joseph Kim. Joseph Kim will provide final remarks.
Okay, thank you, Sam. 오늘 바쁘신데도 불구하고 심포지움에 참여해 주신 모든 분들께 이제 깊이 감사를 드립니다. 중간 진행 과정에서 약간 저희가 미흡한 점이 있었는데 널리 이해를 부탁을 드립니다. 오늘 이제 이 심포지움 내용은요, 앞으로 1년 동안 누구든지 들어와서 보실 수 있도록 소시오 플랫폼에 올려놓을 예정입니다. 다시 한번 코비드-19 상황에서 모든 분들 건강하시기 바랍니다. 내년 심포지움에서 다시 뵙겠습니다. Thank you all the participating in the symposium despite your busy schedule today. Today's event will be posted on the social platform for anyone to come in and see during an year. Once again, I hope everyone stays healthy in COVID-19 situation. See you again at the symposium next year. Thank you so much.